1 second, yeah. You should go over here. I'll have him walk over here. Yeah, Chairman, I'm going to bring you up to do the opening remarks from here. All right, is our AV working? Hello? Hello? Does that work? Hi. Does that work? Excellent, great. Thank you, everyone, for coming to this inaugural AI forum here at the FCC. If we could, we're going to open up the demos after the presentation, so if you guys could try to find seats, that'd be fantastic. We have some seats over here, seats up front. Guys, I am so thrilled that this is happening today. My name is Nathan Leamer. A number of you have been emailing with me, so thank you for helping me make this inaugural event a thing. We have a fantastic panel. We have a number of experts who are just wonderful, and I've got to know them over the past couple weeks. And so without further ado, because we have a big day, I'm going to hand it over to my boss, Chairman of the FCC, Ajit Pai.
Well, thanks so much, Nathan, and thanks for your work helping to set up this forum on artificial intelligence and machine learning. And good morning to all of you. Welcome to the FCC, and in particular to this first forum on artificial intelligence and machine learning. It is such an honor to host such a knowledgeable and talented group of entrepreneurs and academics and technologists to share their expertise on what AI and machine learning are and how they could help shape our society. This will hopefully be the first of many forums, or fora for you Latin sticulars, on where our agency will showcase and learn about the ways that these different emerging technologies, such as AI or quantum computing or blockchain and the like, are benefiting consumers, transforming our economy, and impacting the communications marketplace. Now, there's obviously great interest in this topic, evidenced not just by the range of people in the room. In fact, last night it was reported that the NBA's Philadelphia 76ers held their monthly team meeting yesterday. And during these meetings, a player gives a presentation on a topic of his choosing. 6'10" power forward Jonah Bolden chose to present on artificial intelligence. Now, suffice it to say, I don't share Mr. Bolden's basketball skills, but I do share his enthusiasm about this topic. And that is because AI and machine learning has such great potential to enhance decision-making processes to achieve better outcomes. Indeed, a 2016 report by Accenture estimated that AI could double economic growth rates by 2035 and boost labor productivity by up to 40%. And this is especially true in our field. AI will have major ramifications for our entire economy, but it could revolutionize the communications space. Here are just a couple of examples of the impact that AI can have on communications. At the FCC each year, we recognize breakthroughs by the developers of new technologies that can assist people with disabilities. Two of our recent awardees have created applications that sound like something from a science fiction movie, but each of them is very real, and each is exhibiting at this forum. Microsoft has developed an app that uses AI and deep learning tools to narrate the visual world, describing nearby people or objects with spoken audio for those with visual impairments. The app's name, appropriately enough, is Seeing AI. The second example is from IBM. Its Content Clarifier is an accessible technology that uses AI and machine learning and natural language processing to make digital content more understandable to those with cognitive disabilities, the elderly, or those for whom English is a second language. Now, one of the great things about this forum is that you don't just get to hear about these and other technologies. You can check it out for yourselves. I'm looking forward to doing just that after this forum is over and learning how AI is having a real-life impact, whether by improving accessibility, or protecting our privacy and data, diagnosing diseases earlier, making networks smarter, or enabling precision agriculture. Now, it is important to note that this event is about discussion and demonstration. It is not about the FCC dipping its toes in the regulatory waters. These are emerging technologies, and when dealing with emerging technologies, I believe that one of the foundational principles for government should be regulatory humility. History teaches us that new technologies will evolve in ways that people don't or can't anticipate, and that early intervention can forestall or even foreclose certain paths to innovation. And this makes it foolish or even counterproductive for government to micromanage, or more accurately, try to micromanage the evolution of these technologies. But it is important for agencies like ours and the American public generally to be aware of and informed about what is on the horizon and the potential impacts on the marketplace that we regulate. For example, our current rules for antennas are framed in terms of maximum power. And this reflects an era when radios transmitted on a fixed frequency in a fixed direction at a fixed power. But today's radios are very agile in terms of power and frequency and even modulation. They're software defined, and we are seeing more and more AI capabilities incorporated into these devices. We at the FCC want to understand how AI can enable individual radios to make much more efficient use of spectrum, all without human intervention. AI also holds the potential to bridge the digital divide, which is the FCC's top priority, that gap between those who have access to next-generation technologies and those who don't. And we'll hear today about efforts to use AI to more efficiently build and operate communications networks, which should result in more access for more people at lower cost. Bridging the digital divide through AI and machine learning and other emerging technologies will help all Americans benefit from the digital revolution, regardless of who they are or where they live. And that, I think, is something that every citizen can appreciate. Now, as you can tell, like Jonah Bolden, I'm pretty excited about today's forum, and we'll be back soon to moderate the panels. But first, I would like to invite my colleague, Commissioner Brendan Carr, to make any remarks that he might wish to make. Thank you, Commissioner.
Thanks, Mr. Chairman, for convening this great forum. This is a really, really important topic. And from my perspective at the FCC, we're very focused on this transition from a network perspective from 4G to 5G. And one of the reasons for that is the forum that we have today, which is by making this transition, we can help unlock the tremendous amount of innovation that we're seeing with artificial intelligence and machine learning. And our upgrade to the wireless network is necessary to enable a tremendous amount of innovation that, as the chairman indicated, we can only sort of see very faintly today. And we know this from looking back at past generations of transition. For instance, when we moved from 3G to 4G, no one would have been able to conceptualize what that upgrade in the network would enable innovators like you to do in just a few short years. For instance, back when we were making that transition, if you were going on a road trip, you would often get in the car and look over at your road trip mate and say, "Did you remember to print out the MapQuest directions?" And they'd say, "No, you have to run back inside and find a printer and do that." Now, obviously, with apps, you can do that right on your phone. Similarly, if you think back 10 years ago to the dating scene, back when I met Miss Carr, this was in the pre-4G, pre-5G, pre-AI era. You actually had to walk up to somebody in person. You had to talk to them directly, come up with words to use, and actually ask them out on a date. Now, the younger staffers in my office say that with a smartphone and an app, a future loved one is just a swipe away. All of these innovations that we could not have seen 10 years ago were enabled and done by you. And our job at the Commission was to make sure that the network necessary to carry those innovations and to enable those innovations got built. And so we got, as the chairman said, through regulatory humility, we got the government out of the way. The U.S. won the race to 4G, and we have this tremendous and innovative app economy. And now we're about to see that happen on an even much greater scale. If we can get out of the way, help the private sector deploy the 5G network, we will see tremendous innovations that you're going to enable through AI and machine learning and bringing it to consumers. One last thing, as we think about this transition, I think of it as sort of three buckets, which is to say, from a network perspective, we have our smartphones and tremendous amount of computing power in the smartphone. And we've got server farms and data centers at the core of the network that has a lot of computing power. And right now we're transitioning to sort of a third way, which is pushing a lot of that computing power off the phone and from the centralized servers to sort of a decentralized edge network approach, that the network itself is getting smarter. The network is going to be carrying a lot more of the computing power that's necessary for these AI and machine learning innovations that are taking place today. So we at the FCC are aware of those big trends and making sure that the infrastructure can get built out to make all of this a reality. So best of luck today on the conference. I thought I'd get some ribbing from the chairman for this attempt at a beard that I grew over the holidays. Actually, it is a public service. I saw on Twitter that Senator Cruz was getting a hard time for his attempt at a beard, and I thought I would help him out by showing people what a truly horrendous attempt at facial hair looks like. This thing looks like a squirrel was chewing on my face overnight, but I thought I'd give it a shot. So thanks again for joining today. We really look forward to the discussion. It's so important for regulators like us to hear directly from you all about AI and machine learning. It reminds me, those in DC, we talk about these issues a lot, but we often don't truly understand it. It's like a few years ago when those in DC would talk about food trucks and blockchain in Austin, Texas, things that we knew were interesting because people told us that, but we didn't really know why people were talking about or why they were interesting. So hearing directly from you all about AI, about machine learning, is going to be very beneficial to us. So thank you. And with that, I'll turn over to another one of my colleagues, Commissioner Rosenworcel.
Good morning. I am so excited that there are so many people here today. This is really neat. We have the opportunity to talk about what I think are two of the most exciting forces in the economy right now. That's what you're talking about today and what we do in these halls every day. And it's the combination of artificial intelligence and next generation wireless and broadband capability that I think is going to remake our world. And every day, there are articles and ideas coming to the fore about how it will change healthcare, how it will change energy, how it will change transportation. And if you just think about it with something like autonomous vehicles, we're talking about cars with thousands of sensors on them, and all of those sensors feeding data to algorithms so that we can make smart choices about where that vehicle goes and what it does. And all of that data comes in over connections that absolutely require gigabit speeds and sub-millimeter latency. So it's this combination of artificial intelligence and communications that I think is really exciting. And if I can get a little wonkier on you than autonomous cars for a moment, I want to talk about two elements of it that are most interesting to me. The first is spectrum efficiency. I'll explain that by saying earlier this year I was at the World Mobile Congress in Barcelona, and I got to speak to this global community that wants to talk about how we manage all the demands on our airwaves. And the bulk of the conversation is about how we take spectrum and move it to market. And the other part of the conversation is about how we change the topology of our networks and build more small cells and towers to accommodate all that wireless traffic. But what I went and spoke about was how do we take our newfound cognitive abilities and bring them into our devices so that our networks themselves are intelligent enough to know what transmissions should take place in any spectral environment. And maybe that sounds really out there, but here's the thing. The Defense Advanced Research Projects Agency is already running a contest to look at just that. And it's got extraordinary potential, so stay tuned. The second thing that really interests me, that I admit is also a little bit wonky and nerdy, is network resiliency. If you look at what's happening in our world as a result of climate change, those once-in-a-lifetime storms are happening every year. Look at the wildfires out west and the hurricanes in the south and along the Atlantic. And what you realize is that our networks are under siege from these new weather patterns. Are there ways that we can take advantage of software-defined networking and virtualization and build facilities that self-diagnose, that self-heal, and that self-orchestrate our response to those challenges? And if that sounds out there, again, we have a standards body that has called for papers on just that issue. Now, here's what I'd like us to do at this agency, because you're getting this all started today with a discussion, but I'd like us to follow up. I'm hoping that we can get our Technological Advisory Council to look at spectrum efficiency and artificial intelligence, and we can ask the Broadband Deployment Advisory Committee, which is already looking at network resiliency, to think about what it looks like in the next generation with artificial intelligence. Because I want to make sure that this discussion doesn't stop with you here today, but that it continues. So thank you all for coming. I am excited to monitor your work today and hear more about your discussions because it's so important and so exciting. Thank you.
Well, we've gotten a brief taste of the future, from the profound connected vehicles to perhaps not so profound, smarter dating, and how AI and machine learning could impact that. But at this point, I want to turn it over to our keynote speaker, Subbarao Kambapathy, or Rao as he is more commonly called. He is a professor of computer science and engineering at Arizona State University. He got his bachelor's degree in electrical engineering from the Indian Institute of Technology in Madras in 1983. He received his master's and his PhD in computer science from the University of Maryland, College Park thereafter. He joined ASU in 1991, was promoted to associate professor in 96, and professor in 2000. And he engaged me on out of the blue a request for a meeting for an hour and a half about these topics, and that conversation almost a year ago has always stuck in my mind, and I think you'll find his comments as stimulating as I have found them. So without any further ado, Rao, if you might take the stage and tell us what to think about in terms of AI and machine learning.
Can I get the slides, please? Oh, great. Thank you all for coming, I guess, early in the morning, and thanks, Chairman Pai, for the invitation. So I am connected to Arizona State University, as well as a couple of other organizations, AI Foundation and the Partnership for AI. I'll talk about them a little later. So let me start by saying, how did I, cross-track across the country in the last week of classes, to experience the beautiful Washington weather. It's because, as Chairman Pai said, about 15 months back, he showed up in my office and basically wanted me to tell him about various things about AI. And being a teacher, of course, if you have a willing listener, that's the thing that we want to do. And then what's more interesting to me is that he seems to have taken notes, and he tweeted about them. And so most of my meetings, I wind up taking notes for my students. So it's great that somebody who's listened to me actually took the notes. So when he asked me to show up all the way here, I thought, of course, I have to show up. So let me start by talking about AI. First thing I want to mention to you is artificial intelligence. While it is all over the news right now, it's not new. It's not new at all. In fact, that faded thing there is my bachelor's thesis back in 1983, before the laser printers were invented, apparently. And then that was still already, I was doing AI graduate study in College Park. In fact, this particular field owes its beginnings to a conference in Dartmouth in 1956, so 62 years old. For most of its time, though, however, people are feeling sorry about people working in AI, because it looked like it's one of these dreams that only crazy people work on. I remember working in University of Maryland, and the software engineering folks will say, why don't you do something more exciting like software engineering instead of AI? And so, of course, there were also a whole bunch of people saying, something like AI, which is reaching human-level intelligence, is just basically impossible, and you shouldn't be bothering, wasting time doing this. Now, things obviously have changed recently. Otherwise, you wouldn't have been here early in the morning. So AI has been talked about as the new electricity, that it's bigger than fire and electricity, that is actually God. And AI is in every possible consumer item. Apparently, that one is a toothbrush that apparently does cleaning of your teeth with AI technology. I'm really, really worried about those kinds of things. On the other side, AI has been seen as a bigger threat than North Korea. AI is been seen as the worst event in the history of civilization. And then, of course, Elon Musk, who is always happy about talking about AI, said AI is likely to destroy humans anyway. So things have been so crazy about AI that you can't even put on a TV show and see a decent episode of BoJack Horseman without totally unnecessary references to AI. Okay, now, I somehow feel responsible for part of this because most of this happened in the last 2 years as when I was the president of Association for the Advancement of AI, that maybe I did too much about making AI great again. But what I wanted to talk about in today's talk is just 3 pieces quickly. One is what just happened in AI from a technology point of view, what has changed, and why is it that everybody and every paper is talking about AI recently. And then the second part is, are we done, which is a little bit about the thresholds that you still have to cross to human-level intelligence, but that's probably the smaller part of my talk. And then the third, where I hope to spend a little more time, is how do we manage risks and rewards of current AI technology? This winds up being very important for all of the government, including Federal Communications Commission. So I want to say a few things about that, and I'm sure we'll get to talk about it more during the panels. So what is AI? The wonky definition, of course, just says basically is the circular one of getting computer artifacts to show behavior that when shown by humans, you would consider it to be intelligent behavior. And then technically in the intro to AI classes, we start with this black box diagram about an intelligent agent design. I don't want to walk you through that. Instead, I want to give you a very different perspective because that might make a quick sense to you. Think about, of course, we think we are the intelligent creatures on the earth, right? So let's look at how human kids start showing different ways of different aspects of intelligence. Kids come into this world, they start showing perceptual intelligence. They can recognize their parents. They can manipulate little objects to put them into their mouth. Then they start showing emotional intelligence, and then they'll show social and communicative intelligence, including language. And then only finally they start showing cognitive intelligence of the kind that they require to pass these crazy exams like SATs and get into universities and then start working for various things, right? So keep that in mind. So the last time AI was in the news, actually, in big time, it was back in 1980s during expert systems time, when all the companies which had variety of rule-based, they had some doctrine about how they are running the companies, and those could be codified as rules, and then you would write them as expert systems, and those would be used, to automate many things. And that was like a huge, big thing at that time. In 90s, we actually, AI had this IBM's Deep Blue system won over Kasparov, so basically ending, in effect, the human dominance of chess. And only in 2000s and more recently, we started doing better at perceptual intelligence, speech, image, and a little towards language. Okay. Now, if you take that, look at that, and then you look at that previous slide about how kids develop the facets of intelligence, you'd start seeing that it's almost the opposite direction, essentially. That AI research has gone in the opposite direction from the way kids seem to show different aspects of their intelligence. And that's a very useful contrast to keep in mind because it explains a whole bunch of things. In particular, this somewhat dense slide actually winds up being extremely useful in getting a perspective on what happened in AI and why all the recent interest. So to understand why AI developed in this reverse order, you have to realize that our intelligence involves certain aspects for which we have explicit theories. So we are conscious of how we do those tasks. And then certain aspects for which we have no explicit theories. We subconsciously do them. Now, it turns out that it's easier to program computers with conscious theories because you are aware of those theories. So that's how actually the cognitive tasks first got programmed, because you know how to play chess. There are rules, so you just program that. You know how your company is being run, so you codify that and you program that to the computer. So that's where the first wave came. Now, the interesting thing is the things that kids have from the beginning, such as the ability to see the world and manipulate things and so on, we actually suck at writing them down as to what the rules are behind them. They're completely subconscious. Okay, so and the way the kids seem to learn them is, I don't know whether you had kids, but they basically just hang around being cute and all, doing nothing and sucking up the environment and taking a long time to learn. And they do that, right? And so that's basically, so when you start doing perceptual intelligence, AI systems had to do what the humans had to do, which is essentially depend on learning, because the humans in the loop can't just give any explicit theories of how to see the vision, how to see a dog. So in fact, there used to be a field called computer vision, a field called speech recognition, and so on. They all became essentially subroutines of machine learning now, because there is no real intellectual new theories that we can directly provide. So that's a very useful thing to keep in mind. The second thing is, why did AI catch attention now rather than back when we were creaming Russian chess oligarchs like Kasparov? Well, Deep Blue, when it won over the Kasparov, for a couple of days, the papers were happy. But then, why do you care? How often do you need to defeat some Russian grandmaster in chess? Whereas now, because of essentially the technologies, the AI technologies, the perceptual intelligence technologies coming onto your cell phones, right? You are actually, the normal people are experiencing the abilities of the AI technologies in their day-to-day life. And suddenly they're realizing, oh my God, this thing can actually recognize my face. This thing can more or less recognize my voice. And then the moment they start doing that, they start actually also closing the examples and say, oh my God, next day, tomorrow, I'm sure robots are going to come over and take over the world. So it's both the fact that it reached a lot more people and the fact that essentially basically the infrastructure helps us to deploy this technology of perceptual technology to each of us, that wound up making a big difference in essentially AI becoming so popular right now as a byword. Now, we will hear about the fact that the perceptual intelligence, most of the perceptual tasks, the specific technology that you keep heard, I think some of the commissioners actually mentioned, the deep learning, it so happens that it's a particular kind of learning technology that wound up being technically the thing that made a big difference in doing vision and speech, and also to some extent manipulation quite well. The interesting thing, I don't want to teach you neural networks here, but the blue part is the interesting part to me, is the theories for this existed back since 1960s, and probably the last big change in neural network technology happened in about 80s. And yet, for most of the time, nothing really changed. What changed between 80s and now is the infrastructure. I give this joke that if you have seen Blade Runner, the movie, go back and see it again and realize that while they were able to recognize the future far away, they couldn't recognize that the TVs would become flat very soon, or that the phones don't have to be big blocks, okay? Because society expands in all directions at the same time, whereas technologists think about their own technology. What changed is the data capture and communication technologies that made large amounts of data available that can actually be used, and of course also some computing technology, so that the same ideas that weren't showing much of a impact before wound up starting to show an impact now in terms of ability to do vision and speech recognition. The other thing that I do want to mention, because I'm at FCC, is that this infrastructure actually sort of, the infrastructure of cell phones and infrastructure of web sort of allowed us to reify our collective subconscious onto the web, okay? So I don't know, those of you who are crazy about psychologists know that Carl Jung basically talked about this collective subconscious. Web is in some sort it's both collective conscious and subconscious because we put all the random stuff and it's all being put there. And the computers can be trained on this data. Now, collective subconscious is subconscious for a reason. It's ugly. It has biases. It's, that's the reason why we don't want to talk about it too much. So if you wind up training your programs on the data, on one hand, you have a lot of data, so you can train, but on the other hand, you might also get all sorts of interesting, unanticipated, biased decision-making. It's not that people are not biased. We know how to modulate them, okay? Once you start training on the collective subconscious, all the Twitter trolls, all the news articles, etc., then you are essentially, you do have a lot of data, but you also are probably getting unwashed data. And that's useful to keep in mind. Now, of course, there are a bunch of things that AI can do that's very interesting at the current state. Right now, for example, just to give you a sense, we can right now, with the perceptual intelligence, we can do better than human accuracy on image recognition of certain kinds. In fact, there is this ImageNet database which has 200 different types of dogs, and AI systems are better at it than humans. I don't know whether we want to be better at looking at 200 different types of dogs, but that is there. We also, and this can also be translated into very useful applications like radiology, conservation, and so on, and that's something that you are seeing every day. The other thing, of course, about AI technology right now is it can essentially reconstruct the distribution of the data that you have seen so that you can imagine more points from that data. The way we have dreams where we think up new faces that we may never have seen is actually possible to some extent. An example of that is those pretty faces on the top are all made-up faces. Nobody is actually there who actually has that face. A system which just got trained on a humongous amount of face data, especially of the celebrity faces, basically started imagining new celebrities who don't exist, but I'm sure they have already a Hollywood agent scouting for their things. We have now the ability to clone voice and, of course, as I said, generate images. So the voice can be cloned. Baidu, I might mention later on, has basically developed technology that just with 10 seconds of your voice can essentially clone your voice now such that they can read anything in your voice. Now, this looks like, oh my God, why the heck would anybody do it? And Baidu said, well, if a mom is too busy, then she can train this, use this technology so that this technology would be telling stories to kids, probably the same kids that were born of the dating that was done without any kind of a human touch. Okay, but that's possible. We are looking for improved language abilities, not anywhere near, because language is actually full intelligence, but we are going slightly better towards that. And then, of course, there's some progress on perception to action. You all probably heard about the AlphaGo. So that's the first part. The second is, are we done? One thing that I want you to think of again is, remember that we've been very drunk right now on the perceptual intelligence part. That's the ability to see the world. How many of you got your job because you can recognize cats? Radiologists actually got their jobs because they recognize X-rays. And I actually think that that's a job that's endangered. My joke is that mamas, don't let your kids grow up to be radiologists because that job, it's gone. Okay. So the point, of course, is that we actually have both the perceptual and cognitive and emotional and social intelligence, and we bring them all together. That's what we do. So there's this guy called Polanyi, who is an amateur philosopher and a polymath, who wrote this book called The Tacit Dimension. His point basically was that for the most of human civilization, starting from the Greeks, people kept talking about the parts of our knowledge that can be explicitly stated, okay? And that he wanted to point out that we know a lot more that we cannot explicitly state, the tacit part. More or less, this is the part I pointed to you before, and he was saying, why is everybody working only on the explicit part, not the tacit part? If you heard the first part of my talk till now, you realize now we are almost swung to the other side in AI. We are actually saying, why do we need anything explicit? We'll just learn everything tacitly by just looking at a huge number of examples. And that doesn't always work. So if you were to join a company, you should be able to recognize objects, but you should also be able to take advice on what their doctrine is so that you can use that, and there should be a more efficient way to transfer this knowledge. So the human intelligence is a beautiful interplay of both tacit and explicit knowledge, and to some extent, don't just think of perceptual intelligence. It has humongous explanation and applications, but you really want both pieces. And that, if without those pieces, all sorts of interesting problems can come that I'll show you in a minute. So in fact, I made up this Serenity Prayer for the robots, which says, human, grant me the serenity to accept the things I cannot learn, and the data to learn the things I can, and the wisdom to know the difference. Okay? So keep that in mind. So there is a whole worry right now about perceptual intelligence-based technology, and whether, in fact, if it makes a mistake, will you know why it made the mistake? This issue of interpretability. Let me show you an example of that. So on the left-hand side, you have a school bus, and then I added some noise to that school bus, so that you get that right-hand side picture. As all of you can see, that right-hand side picture is an ostrich, right? At least that's what most state-of-the-art vision systems would say, okay? Similarly, the doggy, with a little bit of noise, carefully added noise, you get this other doggy, you think it's a doggy, it's actually an ostrich. So I am from south of India originally, and apparently there's nothing sacred. You take a temple, add a little bit of noise, it too becomes an ostrich. Now, it's possible that unbeknownst to all of us, the world is full of ostriches. We just didn't notice it. And let's not get carried away with our own visual abilities. I don't know how many of you have seen that picture. This is a picture taken from Norway, our favorite country of immigrants, if you know what I mean. And there, at one point of time, some right-wing nuts basically put up this picture on the Facebook there and said, oh my God, look, our country is being overrun by burqa-clad Muslim women. We need to do something about this, like maybe build a fjord or something. But anyway, now you probably, I'm hoping that several of you can see that they are not burqa-clad Muslim women, that they are actually city bus seats. But you may feel sorry for the bigotedness of the bozos who basically said what they said, but you can almost understand how they thought that picture was misconstrued as burqa-clad women. Because while we have perceptual fallacies, we have an understanding of our fallacies to some extent. Now, if I told you, now that I've already shown you that the right-hand side pictures are all ostriches, do you see now? No way. And if you don't understand the failure modes of a system, you should be very careful about where you are using them. So it turns out that some people drunk on the ability of basically training the data on, training on large amounts of data. In China, there was this paper actually that was published and submitted to a technical conference. Thankfully, it was rejected, where they basically trained the system on a huge number of mugshots of known criminals and mugshots of people who haven't yet been shown to be criminals. That's you and me, okay? And then they basically found that the system can have 98% accuracy in predicting whether a held-out face actually belongs to a criminal or not. Would you want to live in a society like that? Now, you might say, China, who cares about China? That's kind of a crazy place. Well, Israel, there is a company which does this for terrorists. So they'll say the picture, especially a face like mine with a nice mustache, and say, my God, you're in big trouble. So there is a company which is selling these classifiers which says, looks at the faces and says, this is a high IQ face, this is an academic researcher's face, this is a professional poker player, this is a terrorist. Now, let's not kid ourselves. In the deep recesses of our brain, we do jump to conclusions. There's a system 1 and a system 2 brain. System 1 jumps to conclusions very fast. The entire point of civilization had been to use the beautiful parts of system 1 while keeping it in check with the system 2, which is this explicit knowledge, okay? And that's something that we need to be very careful about. So I actually, being a teacher, my biggest problem has been grading. And so what I have decided is that I will train a system with my students' faces from the previous years and the grades they got. And when I get a new student, I just submit that to this grading program, and it'll decide what the grade should be. So you should be using AI technology. So the other thing that I want to mention is what are the various thresholds that you still need to cross to get to the human level intelligence. The things are common sense. For example, common sense is this thing that sort of connects all the loosely coupled pieces. My favorite example is, I tell you just now that the explorer Magellan went around the world 3 times. On one of his trips, he died. Question, which trip did he die in? Those of you who are laughing, you're okay. Those who are not laughing, you're probably robots. You should be worried. Right? So this is common sense. Where did it say in what I said that Magellan died in the 3rd trip? You use this extra information to fill the blanks. We all do this. We take this for granted. And however, AI systems do not yet have that ability. There's a lot of work in trying to do that. Handling incompletely specified information, learning from very few samples. Most of the learning technology right now requires like 1 million examples of anything before it can actually learn it. We typically get shown a couple of examples. As a teacher, I hope 1 example should suffice. My students are always complaining the teacher doesn't show enough examples. And I say, hey, you're a human. You should learn from 1 example. Okay. And then, of course, interaction between AI and humans. This is actually going to be very important, too. In fact, this is something that's close to my heart that in February, I gave a talk on challenges of human-aware AI systems at AAI as my presidential address. If you're interested, you might want to look into that. So in particular, in AI systems working with humans, they need to have a notion of the intentions that the humans might have and should be able to project their own intentions. So if you have an autonomous car, it should be able to tell what the other drivers on the street are trying to do, and it should be able to also project its intentions. I'm about to run you over, or I'm about to turn right-hand side, and so on. Furthermore, actually, it's also important to have a model of the human's model of the system so that it's your model of what I think I'm capable of right now that will make you decide whether what I'm doing is interpretable to you or not. If I start jumping up and down right now, you would be surprised because you didn't think that's part of the bill. And so if I am actually being bitten very badly by a big bee, then if I start jumping up, then I should tell you, oh my God, something is biting me, so now I'm jumping around. And that's the notion of explanations. And AI systems working with humans have to provide explicable behavior and explanations, and that winds up being very important. So the last part is how do we manage risks and rewards of current AI technology? First of all, blue skies, green meadows, AI is beautiful. There's a large amounts of great things we can do with AI. It will have very big impacts on quality of life, universal access, social good, intelligence augmentation. I can go on and on. If I'm going to talk next few slides about the things that can go wrong, it's not because I don't think AI can do humongous amount of good. It's exactly because I know that AI can do humongous amount of good. I want you to also know what things can go wrong. Okay, so remember this. So every technology is a dual-use technology. It can be used for good as well as bad. Intelligence is the ultimate dual-use technology. Okay, so you can use intelligence to do all sorts of interesting things, but it can also start being used for adversarial purposes. I want to talk about 2 pieces that are relevant to FCC. One is bias and manipulation, which is how do we, given that lots and lots of systems are going to be making decisions based on the data that's available on the web, how do we ensure that there is fairness and transparency to the decisions that are made? Remember, you didn't understand why that right-hand picture was an ostrich. So if an AI system tells you, I'm sorry, your credit card application is denied. I can't explain to you why, because you may be looking a little bit like Ostrich. That would not be a good explanation. So how do we deal with these fairness and transparency issues? There is a large amount of worries about this. For example, there's already work on looking at machine bias, the fact that criminal justice system seems to be somewhat biased. It was always biased. It was individuals doing their biases. Hopefully some individuals are okay, some are not. But now if you centralize those biases into a single system, then you are in bigger trouble because it's now going to perpetuate those biases. That is something that we need to worry about. In fact, this is my favorite one. Apparently, ETS said educational testing service found that the SAT testing service people found that you can charge Asian moms more because they're likely to want their kids to do well in SATs. So they charge them more and they charge some other people less. Again, all sorts of profiling has been done. You can be very worried about this, the fact that AI can actually help perpetuate these biases. Two things. Remember that if you learn from the subconscious data that's available, you are going to learn the biases that's inherent in the data. And second thing, the reason I'm showing Martin Luther King is back when, during the civil rights movement, he basically said the following thing, that let me put everything that's going on the streets onto the TV so that everybody sees it explicitly rather than forget about it. And if they feel comfortable with it, the society will remain the same. If not, it will change. AI can be a mirror. AI can put a mirror to us because by actually showing the biases that are inherent in our decision making, we have to deal with it. There was a story recently that Amazon tried to have a job screening system and a recruiting system that was shown to be sexist. So they stopped it. It feels good to say Amazon did a good thing because they stopped this sexist program. Where did the data for this program come from? It's from Amazon. It's from other technological companies. We just hope that if I just do it one by one, there's no bias. But when you aggregate, there is bias. And in fact, the fact that this is shown is something good for us. There was a very interesting work by some researchers who basically showed that the commercially available face recognition systems from Microsoft, IBM, and so on actually are pretty bad at even recognizing gender for everybody other than the balding white men here. They're 100%. Everybody else sucks. Okay, so if you're from Africa or India, a man can be seen as a woman can be seen as a man, etc. This is pretty bad. Now, you can say, this is all huge bias on the part of Microsoft and Intel and Microsoft and IBM. The reality is this is data bias. You are learning from the data that the system is learning from the data that is provided to it. So what is important is to make available diverse amount of data. In the past, you will just take a couple of white faces and a couple of other faces and they say this is enough because this is the maximum amount of pictures we can get. Now we don't have that problem. We have humongous infrastructure to collect data. So it's important to provide diverse data available. Another interesting thing is if you provide biased data, one thing that the technology does these days is to augment the data, if it's not enough, to augment the data by imagining more data of that type. Now, unfortunately, if all you have seen is white people, you will have dreams of white people. All you have seen, the reason, in fact, we mostly dream of people is because we seem to interact mostly with people. So our imagination is limited by the data on which we are trained. And so it can give you a false sense of security if you think that somehow I generated more data from the few pictures I had. But in fact, that particular thing shows my students basically trained a GAN system on a set of engineering professor headshots, and then made it imagine more engineering professors. Now, these look like augurs, I understand. They're malformed faces, but they're all male malformed faces if you look at them closely. So in essence, the system is internalizing the biases that were provided in the data. And the other thing to remember about any of these AI systems is this is between correlation and causality, and most of the knowledge that the learning system learns is a correlational knowledge, and we should never confuse correlation and causation. Correlational knowledge is very useful sometimes, but our jurisprudence, thank goodness, and all our higher level thinking depends on causal models and causal knowledge, and that's something we have to keep in mind. The second thing, and that's the last thing I would talk about, is the big set of attack surfaces that AI technology, especially the perceptual AI technology, is going to make possible. We now can spoof voice, we can now spoof images, we can then spoof identity. Because as some old TV show, I think, Moonlighting, there's this quote saying, if only people didn't have eyes to be sure with, they would be much harder to fool. We believe what we see. And so if I can make you believe by showing a made-up image, then you're likely to believe it. If I can give you a call with your mother's voice saying, please send me those $10 that you said you will send, you will send. Okay? So we are talking about robocalls. Voice spoofed and identity spoofed calls are going to be much more interesting problems that FCC will have to deal with. We already have that. We can generate new environments. We can actually, there are videos on the web, for example, making Obama or Trump say anything you want them to say. I know some of them already say that, but others can also be made to say whatever it is that you want them to say. Okay, and this is that Baidu technology that essentially allows you to spoof the voice. In China right now, there is an AI anchor which does news. Okay, so it's obviously real fake news. And finally, even if you are talking about humans in the loop, human-aware AI technology, when the systems start modeling our mental states, that can actually be used as a powerful way to manipulate us. In fact, I don't know how many of you have seen the amazing movie Sting. The older people may have. And the entire movie is a setup, and which is basically manipulating the mental model. When the AI systems start doing that, because other people are controlling those AI systems to manipulate you, we have a whole entire set of problems. I mentioned that I'm connected to this company, which for-profit and non-profit pieces. In their non-profit piece, AI Foundation has been doing something called Reality Defender, which in essence tries to start looking at, can we look at putting up a fight for fake reality, manipulated images. Can you actually recognize them? We are not the only ones. There are a whole bunch of other researchers are looking into this. But again, we use the AI technology to fight AI technology. There is no other way of going out of it. Okay, I don't want to talk about unemployment. I think FCC has full employment, I believe. I want to end with essentially the Pandoras Box. It looks as if we opened a Pandora's box, at least the way I made it sound. But remember, first of all, technological progress can't be stopped to some extent. And secondly, as much as people keep talking about Pandora's box, what people forget is that after all the devils escaped out of the box, Pandora finds inside the box hope. Okay, there is still a lot of hope in terms of using this technology, and that's where we need to have wisdom. What does FCC and government can do? We should be supporting good uses. It is important to note that all beneficial users of AI are not necessarily going to have commercial benefits, so government should be stepping in. We should be supporting democratization of AI. Currently, because of the fact that humongous amounts of data and humongous amount of computing power are needed to train some of these systems, big companies wind up having a pretty big advantage. People, even in universities, are at a disadvantage. For now, the companies are well behaved. But we don't build democracies by hoping that corporations will behave well all the time. Okay, so we want to be ensuring that there's a democratization of technology so that anybody can develop AI systems and we can have competition. We should be working towards mitigating adverse effects. FCC should be protecting reality. That's what you guys do when you stop robocalls, because that's not reality. There's random calls that are being made to me. I didn't want them, and you're trying to stop them. Your job is going to become a whole lot worse, because now these robocalls are going to be coming in assumed identities and assumed voices that would be very hard to tell apart. You want to combat data bias. You want to make sure that the corporations are making sure that the data that which they're training their systems are having diversity. Don't kid yourself and think in terms of algorithmic bias. No company sits down and writes a program that says, let's be racist. No, that's not what happens. What happens is the data that they're working with winds up just happen to have the bias is built in. My example of that is Samsung at one point of time made a camera that had a blink detection feature. And this blink detection feature would say to Japanese and Koreans all the time, they're blinking, they're blinking, they're blinking. Now, Samsung is a Korean company. They were not trying to insult their own customers. What they did was they did the bozo thing of training their system on just the US data. And that's not right. So that's the important thing to keep in mind. And of course, there are vehicles for doing this, educational efforts, R&D funding, and capacity building. What we shouldn't have to do, I would say, avoid excessive regulatory zeal on AI technology itself because somebody like Elon Musk told you to do that. As I basically say, we are far away from singularity. Stupid ways of ending civilizations are already present right now. Thermonuclear bombs have been invented long before AI. Okay, but intelligence is not your biggest worry right now. That's not what we should be thinking about. We should take the existing technology and looking at what are the things how to ensure that it is used in a fair way. So I will stop there at that point. And actually, I work with AAAI, which has a conference on AI ethics and society, which looks into some of these issues. I also work with Partnership for AI, which is a private sector initiative and private sector nonprofit initiative in looking at best practices for AI. I can talk to you about it more. I should show my students' pictures so that it will show up on the live webcast, and I will stop here. Thank you for your time.
Well, thank you so much, Ralph, for that presentation. I think all of you who are watching here or on the live stream got a little sense of why I was so intrigued and soaking in all the information he gave me when I was in his office in Arizona. At this point, we're going to start the first panel. Rao is one of our panelists, whom you know, and then we will turn to Dr. Carolyn Nguyen. She's a director in Microsoft's Technology Policy Group, which is responsible for policy initiatives related to data governance and personal data management. And her work is focused on helping to shape relevant long-term technology policies globally in these areas by engaging with stakeholders and raising awareness of potentially disruptive impacts of emerging technologies, such as big data, AI, the Internet of Things, and the like. She's held a number of positions as well with companies like RIM and Avaya, Lucent, and Bell Labs. She received her PhD from the Center of Telecommunications Research at Columbia and finished as well executive business management programs at Harvard Business School and London Business School. Dr. Nguyen, thank you very much for being here. Additionally, we have David Cox here, who is the IBM director of the MIT IBM Watson AI Lab, which is a first of its kind academic industry collaboration between IBM and MIT. And it is focused on fundamental research into artificial intelligence. The lab was founded with almost a 250,000 10-year commitment from IBM, and it brings together researchers at IBM with faculty at MIT to help tackle hard problems at the forefront of AI. Before joining IBM, David was the John L. Loeb Associate Professor of Natural Sciences and Engineering and Applied Sciences at Harvard. He was also a faculty associate at the Berkman Klein Center for Internet and Society at Harvard Law School, and is an agenda contributor at the World Economic Forum. And in looking at the resumes of these two, I'm sharply keen of my own limitations and will try to moderate the discussion as best I can. And Carolyn and David, if you wouldn't mind joining us on the panel, that we can get started. So I thought we might kick things off with some opening remarks from each of the two of you. I think Rao's given us a very compelling presentation and helped us frame our thinking about these issues. And feel free to dive deeper in any way you see fit.
Please do.
Great. Thank you so much, Chairman Pai, for the introduction and also for enabling us to be a part of this really fascinating discussion here, and also for the wonderful, to Rao, if I may call you that, for the wonderful intro to AI. I just want to make 4 very short points. To your point, Chairman, about the need to understand these emerging technologies much better by everyone involved, or maybe involved in any sort of a governance or policy or regulatory aspect. Completely agree. With my technical background, that's what I do. What I say is I speak 2 languages, right? Technology and policy. And that translation is really, really important. So to that light, in terms of the 4 points, the first one I want to start out with is to build upon a little bit in terms of AI's ability to enhance our capabilities, because at the end of the day, it starts with all of us. And, the notion is that, therefore, AI can help us to establish better insights and empower all of us to create better solutions, transform whatever it is that we're doing into much better than what we were doing before. The way at Microsoft we look at it as AI sharing additional intelligence and insights to make us go to that next level. It is about empowerment. It is about helping us to solve society's biggest challenges. We've got 2 applications that we're demoing here, and one of the things I want to go directly to your point about bridging the digital divides, which is, so the example here, we start with the concept that a farmer who knows the temperature, pH, and moisture level of his farm will be able to make much better decisions in terms of when to plant, how much to water, and what to plant. So in the U.S., 20% of people living in rural areas don't have access to even the slowest broadband speed. So in working together with Dancing Crow Farm in Carnation, Washington, what we've done is to build out, enable them to have access to broadband through a technology called TV Whitespace, then build up a very cheap infrastructure, which is solar powered, that enables that farmer to collect soil condition, moisture condition, how the farm is doing, the crops, etc., send that information back to a server that can analyze this using existing climate data, etc. So the end result is that that farmer is now using 30% less water and 44% less lime to control soil pH. So that's sort of one area in terms of how we see AI's potential. To realize this potential, we absolutely believe that we need to make AI human-centered. What this means is to amplify human ingenuity with intelligent technology. What that means is to couple what AI is really good at, which Rao has really made an excellent presentation on, which is learning patterns and developing insights from large data sets, with what humans are really good at, which is creativity, empathy, fairness, judgment, and collaboration, right? How do we actually figure out what is the problem statement? Trained as an engineer, that's the first question. What is the problem statement? And humans are really good at doing that. And then how can you use, what is the capability of the AI that can be used to help solve that problem? Thirdly, to realize AI's true potential, what that means is enable its broad adoption. It's got to be trustworthy. And I think you made that point very well. And at Microsoft, we published a book earlier on this year called The Future Computed, where we lay out what are the 6 principles to make AI trustworthy. We use the word trustworthy in terms of ethics because ethics is very much of a social cultural construct that is very context dependent. And those principles include, to your point, fairness, or I should say lack of bias, privacy and security, safety and reliability, inclusiveness, but also mechanisms to address and identify those things in terms of transparency and accountability. For the conversation today, I want to emphasize primarily inclusiveness, which gets back at the comment, the chairman's comment with respect to enabling and extending opportunities to those who don't have those opportunities before. What does that mean? How can AI empower everyone, regardless of age, ability, or language, by creating opportunities, redefining their lives in terms of making them socially more integrated, better integrated into societies, and or professionally integrated by being better integrated into the workplace. For those of you who are old enough to have read Douglas Adams' Guide to the galaxy, Hitchhiker's Guide to the Galaxy. Remember the Babel fish, right? Those things that you put in your ears that allows you to understand every intergalactic languages out there. Well, that's kind of what seeing AI does, if you want to go look at it, right? That's what AI enables you to do, and that's that perfect example of human-centered and augmentation. At Microsoft, those are the kinds of applications that we want to emphasize, and we don't know what each of you individually have the ingenuity to do. So what we want to do, again, is, for example, we launch a program called AI for Good Initiative, which is a $115 million program over 5 years, and AI for Accessibility is a part of that, to reach out to subject matter experts to say, hey, if you have these insights, if you have this computational intelligence, how would you use it to address accessibility issues? Right, so that's one of the programs that we have out there. So we all need to work together to shape this future. It doesn't just come out. And I think this reinforces the point from the chairman has made and also that Rao has made. It won't just happen. We need to work together to drive the development of AI to be human-centered, trustworthy, and truly able to empower people. AI is not just a problem, it is also a part of the solution. And to that point, I think that's why we're here, and that's why we really, really appreciate the opportunity to just say we need to understand this technology better. Thank you.
Terrific. Thank you, Carolyn, for those comments. And if I might, David, the floor is yours.
Thank you. And thank you, Chairman, for inviting me. I'm a recovering academic, and as Rao mentioned, academics crave a willing audience. I would just modify it and say that the willing part isn't actually all that important, so thank you all for coming and listening. I just want to emphasize a few things that Rao said and put a slightly different framing on it. As a recovering academic, I would say actually before 2017, this whole forum's about AI. My business card actually says AI on it in 2 different places. But before 2017, we were actually really uncomfortable saying the term AI. We really desperately wanted to call it machine learning or deep learning, particularly in the academic community. And I think in 2018, we all kind of gave up, and we're all calling it AI, and we're really embracing that. But when I came to IBM, which is my first foray into a big corporation, they had done something really nice, which I really like, and I think it frames the discussion in an interesting way. They put adjectives in front of AI to distinguish what we have today, which is narrow AI, tremendously powerful, disruptive. If it solves your problem, it's amazing, but it's limited in fundamental ways. And then on the other side of the spectrum, we have general AI, this idea that Elon Musk has, that we're going to have systems that become conscious and self-aware and they're going to take over the world or whatever. When IBM internally thought about when that might happen, we came up with a number 2050 and beyond. And when you ask scientists when something's going to happen and they tell you 2050 and beyond, that means we have no idea, but it's really far away. But what's in between those 2 parts of the spectrum, I think, is really what we're talking about today, and that's the stakes. And we call that broad AI. So what will it take to have AI be broadly applied across many different, basically every corner of enterprise? And I think there's a couple key things we need to build. And the lab that I run, which is, again, it's a joint lab between MIT and IBM. It's founded with a $250 million investment over 10 years from IBM to usher in broad AI. And what we need are several things. One is we need systems that can learn from small data. So as much as we talk about big data, actually, many enterprises, many problems don't have big data. So the 200 examples of dogs, there are many problems that just don't have that. In the limit, think about a network intrusion attack. If you want to have AI figure out that somebody's trying to break into your network, you're not going to get 10,000 examples of that network intrusion. The first time it happens, it's happened, right? You don't get any training data before that. Likewise, when my daughter learned what a cat and a dog were, I didn't sit down with her with flashcards and say, cat, 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 dog, dog, dog. She saw one cat. She looked at a dog and said, hey, kitty. And like, no, honey, that's a dog. Boom, she's got it, right? So we have this ability ourselves. We need to replicate that ability to get it into every corner of the enterprise. But even more than that, a big part of the technology transformation that's coming, and I think every organization, every enterprise recognizes that AI is going to transform how you do business. That's as much a people transformation as it is a technology transformation. So not only is technology going to change how you do business, how government does business, how nonprofits do business, it's going to change the way we work. which means that the technology has to meet us halfway. That means it needs to be explainable. We need to understand. We need to trust why it's making those decisions. It needs to be fair. It needs to be unbiased. That's going to, as Rao, I think, beautifully said, that forces us to hold a mirror to ourselves and really ask, are we unbiased to begin with? What does it mean to be unbiased? What does it mean to be fair? These are actually really complicated questions. And I think AI has the potential, as we build these technologies, to do this in an automated way, to help us as a society figure out what we mean in the first place. So we need systems that are explainable. We need those explanations to be correct. It turns out that there's a danger as we build explainable AI that we build systems that make explanations, but those explanations might not actually be true. So one time I came into the kitchen and there was a broken cookie jar on the floor, and my daughter had a beautiful explanation for why that was true. It just turned out it wasn't correct. So we need to build AI systems that can actually be fundamentally interpretable, and this idea of causation versus correlation comes into that. So if you really understand the causal structure of what's happening, that's one way that you can get systems that are intrinsically interpretable, and that's something we're very much investing in the lab I run. And then the last piece I just want to highlight is a notion of infrastructure, which also Rao brought up, which has been intimately woven into the fabric of this AI discussion from the very beginning. I will also note, there was a comment that the term AI came in the 50s from a workshop at Dartmouth. That was actually a workshop that was organized by an IBMer, Daniel Rochester, who was building the first practical computer, the IBM 701, and future MIT professors, including Marvin Minsky and Claude Shannon. So we've been together since the beginning. But infrastructure has really been an important part of this, right? Like, what are the machines we're building? And currently, the machines we're building, are causing significant harm in the long run to the planet Earth. So by some estimates, just the power consumption of computing, if it keeps on its current track, by some estimates by the year 2040, will exceed the power budget of the planet Earth. So there won't be enough solar radiation coming from the sun. There won't be enough stuff we can dig up out of the earth and burn to actually keep up with how much computing we're doing. And that's even if you leave Bitcoin aside. So AI is going to need to become lower power. We're going to need to think about new computing architectures. And this is a tremendous opportunity, because as we lower the power consumption of these devices, that means we can have vastly more power available in the cloud, but we can also have power available, AI intelligence available at the edge. And that opens up a whole new spectrum of different applications. And this is, again, something we're working on, looking at new analog computing architectures that could perhaps reduce the power consumption of AI by 100 or 1,000 times. We're also looking at quantum computing, which is an area where IBM has a really strong leadership position, and asking how can AI and quantum interact with each other. So we're taking this broad view that really, to get AI everywhere and to allow AI to augment what we do, we really need to break down these barriers. And I think that's a discussion that we need to all have together. That's a discussion where every stakeholder has to come to the table: technologists, policymakers, the community, and we need to decide together how we're going to make sure that that revolution comes to life, and comes to life in a way that serves us all. Thanks.
Thank you. So if I might start off our discussion with a very government-centric question, since we are, after all, here in a government building. You've given some very interesting perspectives, and I think you've identified some very interesting pressure points, if you will, with respect to AI. Now, I made in my remarks the general principle that we should view these emerging technologies with some restraint as a government, let them develop organically. But how would you respond to the argument that, well, look, if the AI module that we're talking about is only as good as the data that's being fed into it, if that data is essentially replicating the existing biases in the real world, then we have a problem. Or if the function or the purpose of the AI module is something akin to what you were talking about in China, we might have a problem. Or even things, as David was pointing out, if the power consumption of these AI tools is out of whack, then we have a problem. So would you agree with, or then modify the statement I made that we should generally be hands-off as regulators and as policymakers on these emerging technologies, or is there a more active role for government, would you say?
So I mean, I think just what I meant to basically say is that there are two different types of regulation. One is regulating what kinds of technologies are being developed. That I don't think the time is right at all for government. In fact, I think people in AI research don't completely understand what things will work and what won't. And so that certainly would be the wrong thing to regulate. But some of the uses of the technology are becoming mainstream enough that ensuring that the data that a company is using has some sort of a certifiable diversity characteristics, that it actually is, is representative of the world in which this system is being used. That is something that is reasonable to look into. And again, as I said, ensuring that there is a sort of a democratization of access so that many new technologies will develop. So I want to put in perspective the fact that for the longest time, the people working on neural networks weren't given a red dime by anybody, because it was a technology that was given up for dead, so much so that the people working on it went to Canada. Okay, so what the reason for that, basically the reason I bring this up is, if we knew how things are going to work, then we would have, kind of engineered the future long back. I think the best thing is to allow basic research to be regulated by the science organizations. But the government does have, I think, a reasonable role in terms of, ensuring access and ensuring that the data being used is diverse for the application that they're using.
Thank you so much for the question. I want to build upon this point here. I think the fourth point that I was making in my remarks is that we all have a role in making sure that this technology is going to be developed in a way that maximizes its potential with the recognition of what the risks are. And I think that so from the perspective of identifying the risk, and I think David made the same point, which is all of us really needs to be at the table to try to identify what those risks are. Bias is one, or identifying potentially bias, making sure that the systems will work in a way that is safe and reliable, is another one, et cetera. We can go down the list. However, does that mean that there needs to be regulation in all of these things? I don't think so, and let me qualify that by saying that there is a governance framework that needs to be put into place, and the first part of that governance framework is to ensure that technology can maximize its potential, and in mitigating that, there are best practices that can be in place when these technologies are adopted in each of the different sectors. And this is where the sectoral conversations will become very, very important, because we don't know how these technologies will be deployed. That will be up. So I think that's why we form organizations such as PAI to make sure that we can share best practices. Standards organizations has a role in this conversation as well, in terms of identifying what is AI, what's the AI system, what's the terminology, what's the reference model, are there potentially what I would call risk management system and processes that should be put in place in a standardized way across the board. And then, of course, existing regulation applies, right? Just because this is a technology doesn't mean that, existing regulations doesn't apply. So I think that we need to look at all of that. And then, if there are specific harms, and, for example, Microsoft has put out, our president has put out a blog to say, well, there are specific harms with respect to facial recognition, that there may need to be regulation. But again, that process really needs to be a multi-stakeholder process and consultation. So that's how I would look at this. One last point, which is something that Rao brought up, which is AI really, as a technology, can be a solution. So I think that that is one part where there needs to be additional investment into both, especially from a government perspective, into longer-term research, especially issues that are societal relevant that industry research may not be addressing, and that's a critical area.
Yeah, I just want to add one thing to the existing discussion. AI is moving very fast. And when something is moving as fast as it is, I think what you're doing here at the FCC is exactly the right thing to do. I think convening, using governments for its convening power to bring experts to have the discussion is incredibly important. And regulation early in the process can be problematic. It can be, even at the level of, you might think a priori that if we want to eliminate bias, well, of course, the thing we have to do is blind the systems to the protected variable. So, like, we just need to make sure that the systems don't know what the race or the gender of the people it's making decisions on are. And there are shades of this in regulatory proposals and frameworks that are starting to emerge around the world. But that's exactly the wrong thing to do. And if you talk to people who are working on the front lines of building these technologies, in fact, you need to know these variables so that you can specifically build the system such that they can factor out those factors. So having that deep technical conversation so that we can work our way through these things, I think is going to be important so that when we do regulate, that we end up regulating the right way. I also think that it's incumbent upon industry to self-regulate as much as possible, and I think IBM certainly has taken the position that we need to. These are key core concerns for us. We are working hard to build the technologies that solve these problems, and that together across industry, we can start to define how we solve these problems before obviate the need for regulation to come in. So I think it's a tremendously exciting time. I think the potential is tremendously large, and if we can work together, governments, industry groups themselves, to define how to solve these problems, before they become problems, then I think we're going to get to a better place in the end.
Those are all great perspectives. And another general question I had, keying off some of David's previous work that I've seen, is focusing on this gap between humans and AI. And I think Rao mentioned this as well with some of the comments that have been raised, and Carolyn as well. The fears, the dark side of AI. Some seem to see it as a continuum, to borrow from pop culture, the Wall-E at the good end and the Matrix at the bad end. We're all going to be tools of these machines. But I'd be curious, David, on how you see the distinction there. What is it that makes humans irreplaceable? Can we, in fact, artificially recreate the brain, so to speak, with some of these technologies?
Yeah, I mean, I think the goal for the near term is very much an IBM's position. I think many companies' position is AI is here to make us better versions of ourselves, to augment us, to give us superpowers, right? Whatever your job is. And we see, in terms of labor markets, AI is not going to replace jobs, it's going to replace parts of jobs, it's going to change jobs, there's going to be a transition, and we think that's really important. Now, in terms of closing the gap, I think increasingly we're going to see AI systems that can do much of what humans can do. I mean, at some level, this is a kind of machine, and it does become an interesting conversation of what do we keep that's distinct for ourselves. And one question I think that came up earlier was sort of, what do you tell your kids they should be when they grow up? And when I speak publicly, I get asked this question a lot, and I've given a lot of thought to it. And my answer is an autonomous vehicle personal injury lawyer. I think that is just anti-cyclical, it's just recession-proof. It's we will always need lawyers. But seriously, I mean, I think we're gonna emphasize more and more of the soft skills. We're gonna emphasize more and more leadership. I think there are many, I think there are many things that AI can't do today, and a lot of these discussions are a little bit premature. But I think the focus, I think the way we chart the path forward is that we really just keep a keen focus on asking, how can AI work for us? How can AI make us better? Right. How can AI make us less biased? Right? People talk about AI being biased. How can we use AI to make us even better than we were natively? Because our human brains have sort of a native bias to them. So I think if we keep that focus in mind, we can get to a good place.
I think I would just add on to those questions to say, what is AI good at, and what is it not good at? What can't it do? And I think we need to be really focused on that. So let me, share a interesting story, right? When Ben Bernanke resigned, he made an application to do free financing for his home mortgage. So he was rejected because he didn't have a job that would cover the amount that he was asking for. So it was rejected. Now, I think that there's a story there, which is a very concrete story about what AI can do and what it cannot do, right? And to build upon the point that Rao had made, which is, AI looks backwards, right? How many of you have seen the wording from any sort of investment company that just says, performance in the past is no, assurance of performance in the future, right? AI is backwards looking. It's not going to be forward looking. And I think those are the things that human beings are good at. We have that overall context. And I think we really just have to keep on asking the question, what is AI good at and what can it not do?
So I don't know if it's probably a Freudian slip or something, but I couldn't help but notice that David mentioned that at least in the near future, IBM plans to keep the humans and augment them. That is actually worrisome to me. I know that he probably didn't mean it that way. If the question of can humans be replaced is a silly question. Who is making this technology? Us. Why would we want to make a technology that would replace us completely? And from a research perspective, AI already does extremely well on Mars. Okay, Rover and Spirit have been having great time on Mars. You know where they have trouble? With you and me. And you know why we have the brains the size that we have? Not to run away from the lions on the savannah, because that's where we all come from, but to actually deal with each other. So in fact, the real question is, can we make technology such that it would work with us as against some clumsy way replace us? And this is exactly, I think, the point I made in February when I gave my presidential address. That was my argument to the technical folks, that really dealing with humans is much more of a interesting research problem, because researchers are masochists. If it's not a hard problem, why would you want to work on it? And actually, working with humans is much harder. Understanding the mental states, using intention projection, providing explanations, as David's daughter already figured out, explanations are reconstructive. We are extremely good at making up explanations that will get us what we want. And understanding these issues really puts forward like a much more interesting future for AI. I think we should definitely use the existing things that the perceptual intelligence in AI can do, but I actually cringe when people talk about the AI as if it is one thing. It's a completely moving target. I hope that's the minimum that you got out of my talk, that in fact intelligences are multifaceted, and we basically are doing extremely well on one piece of it right now. I did also want to mention two more points. One is, I think the reason I showed up here, honestly, is because I keep getting asked by other governments to show up and talk about AI. We did do, and in the US, actually, there was a lovely effort, I think in the previous administration, called Preparing for a Future with AI, where they essentially got huge number of the stakeholders and did a very careful study of how AI technology is going to impact the society. There's been a lull in that. I haven't seen that being picked up. So I'm very happy that it's again starting. And then finally, with respect to what should you tell your kids when they grow up, honestly, I would say this is going to be the great revenge of liberal arts. All these history and English majors that we make fun of because they don't know how to deal with Excel spreadsheets. Excel spreadsheets are boring. Those are the kinds of things machines should be doing. We should be doing liberal arts education. I think, in fact, that's what is going to happen. Liars will be automated much before everything else.
As the lone humanities major in my rooming group, who was often the butt of those jokes, I very much appreciate that perspective. Unfortunately, we are near the end of our time, but I wanted to give you a chance, any of you, to augment what you have said, or if there's anything we haven't had a chance to discuss, or any closing remarks you might care to make. And this will start in reverse order with David.
Sure. So Rao, I'm not exactly sure what you think I said, but it's. I think the key thing here is we should have a discussion that's informed at all times, right? So we should have discussions like this. I think this is tremendously important, and I thank you for organizing this, because I think this is fantastic. Where are we today? What can AI do today? And today, we're nowhere close to the point where we can replace humans, right? Like it's very much. And there are limitations to what we have, and there are places you shouldn't deploy AI, and there are places where you can get great social good from deploying AI. So we should constantly ask ourselves, what can AI do today, and how can that work best for us? And if we keep that guide star, that we're constantly asking those questions, what does it really do? What are its limitations? Let's not get caught up in hype. Let's not get ahead of ourselves and hype either good or bad. It's not as scary as some people seem to think it is, but at the same time, it's not as sort of magically powerful as some people seem to think it is. Getting a really nuanced view, and I think that's going to require people in policy to really become experts in technology. So, sorry to the liberal arts majors of the world, like we absolutely can do it, and it's powerful, and I think the fact that you're showing this interest and this curiosity is exactly the right thing. Just kind of have that nuanced view and just keep asking those questions, and then together I think we can do something really great with AI.
Thank you. And so a couple of thoughts just to expand on that. I think that we do need to all come together to make sure to shape the development of AI to be human-centered and trustworthy. That will require a multidisciplinary conversation, not just liberal arts, all technologists, policymakers, academics, civil society, business, health experts, manufacturing, retailer. Everybody really needs to be at the table to have that informed and nuanced discussion before any regulation. And to that point, I also want to acknowledge the FCC and USG's help in the recent ITU Plenipotentiary Conference, in terms of being able to address, conversations in AI at the global level.
Very much appreciate that. And Rao, anything in closing?
Thank you. So just 2 points. One is, I think Carolyn was asking me earlier, and also you brought up about negative perceptions of AI and whether public is too worried about AI. Actually, I think there are two problems. One is either people are too worried about AI or too happy about AI. Okay, I think we talked enough about too worried about AI. I think if any time you think AI can do lots and lots of things, basically wake yourself up and realize that the technology is not where it is. Humans have an example closure tendencies. If somebody can do integration in calculus, you assume that they can do differentiation, they can do multiplication, they can do addition, subtraction, because that's how the humans doing the integration are. But I can give you a machine which can do integration and does nothing else. And it's extremely important to understand that. Just to give you an example of that, I was in Chile last week, and then so I tweeted saying, Veni vidi vici Chile. And a certain high-profile company's translator translated that as, I saw you in Chile. Okay. Okay, you can find out which that company is by going to my Twitter. But I think it's very important to have a balanced look on the technology and not be essentially being prey to these extremes. Thank you again for the opportunity.
Well, thank you so much to all of you for sharing your expertise. And I think the folks who are in the audience will agree that we are very much beneficiaries of your knowledge and look forward to applying it, not just on the next panel, but in the future discussions. So thank you so much for taking time away from your busy schedules to share your knowledge with us. And we will very much appreciate it. So if you could give them a hand. Now we'll take a brief 5-minute break and then convene with the second panel at about 11:07. This is great. Hey, good to see you, man.
Okay, thank you very much for staying and being here for the second panel. My name is Eric Berger. I'm the Chief Technology Officer at the FCC, working for the Commission. I want to thank the Chairman for this opportunity to bring together both the first panel and this panel of very distinguished people in the AI realm. on that first panel, you heard a lot about AI, a lot of the optimism, a lot of the things to be aware of. But one thing I wanted to talk briefly about is how AI, like a lot of technologies, are an opportunity of taking what people used to think of as a zero-sum game. If I get something, it means someone has to lose something. And where through technology, we can actually, in a sense, create more of that something. There's more of a pie to share. The people we have in this panel are people who are actually building and using AI and machine learning in their everyday products, and ranging from healthcare to keeping their own internal network safe, all the way through to actually some really cool things that'll be probably coming down the pike. And, oh yeah, we're at the FCC. Boy, how can we do more of the spectrum stuff and more of this network operations? So I'm going to kind of, well, actually, I'll go from your right to left. Youngmin Wei is from Qualcomm. Now, you might have known of Qualcomm as a chip provider for phones, but that chip stuff comes down to doing high-performance CPUs with hardware optimization for AI. Why? Reduces power. Why? So we can put that at the edge of the network, not only in phones and base stations, but even in watches. He particularly has been focusing on 5G IoT applications, but as you start thinking of 5G IoT, you start thinking of things like spectrum sharing and efficient usage of resources. Next to him is Subha Madhavan from Georgetown University. She was one of the early pioneers in using big data and AI and machine learning applied to medicine, more especially to oncology. She was just appointed Georgetown Medical Center's chief data scientist, and I will do some shameless promotion here. Starting a new Master's of Science in Health Informatics and Data Sciences, and one thing I think she's going to talk about a little bit is a MOOC that she's been running for the past few years. Next to her is Michael Hayes from the Consumer Technology Association. This is also the pitch for like a place like Georgetown, a liberal arts university doing a lot of science. So having sort of the consumer view, the new technologies, things we're going to be seeing coming down the pike. Next to him is Chris White from Nokia Bell Labs. You might have heard of Bell Labs before. Yeah, this is the FCC. He, in particular, runs the Algorithms, Analytics, and Augmented Intelligence Research Lab. And there in that lab, they actually also run the gamut from just the basic mathematical and philosophical foundations for AI and machine learning all the way through to 5G applications. And finally, Matthew Rutley from Frame.io. Now, Frame.io is a video collaboration app. You can think of it as applying Slack to video production. So you might be thinking, what's the AI thing there? Very, very important for the operations of his company. He's going to talk about that. So with that, I would like to hand it over to the chairman. Again, thank you very much for having this panel formed.
Thank you very much, Mr. Berger, our guest CTO, for introducing our distinguished panelists. And thanks to each of the panelists for taking the time. I thought we might just start by giving each of you a chance to have a few minutes to discuss your perspective on AI and how it might impact the communications marketplace. I might as well start with my immediate companion, Matt.
Sure. So thinking about the kind of networks that transfer all of the data powering all the applications in our phones that we access in our offices, they're all transferring now huge amounts of information, especially if you're an engineer. We're dealing with gigabyte, terabyte, even petabyte level data sets, especially if you're using machine learning or a startup like Frame.io, which has an enormous amount of video content, and being able to get your if you're a client of Frame.io, being able to get your video content onto our platform as quickly as possible is absolutely imperative and is something that is critical to our business.
Chris?
Okay, thank you. Yeah, and in many of these forums talking about AI and the future of work or AI and the implications, I like to actually substitute in computers for AI and think that the meeting was happening 20, 40, 50 years ago. And I think it has the same kind of potential of revolutionizing the world that we're in. Intelligence is about scarcity, right? The only reason why we need to be intelligent is because we need to solve problems and actually deal with a scarcity of resources. If we had infinite resources, why be smart, right? And I think that the way we think about intelligence is the automation of the mundane, right? The tasks that we do that don't require lots of thought, that we do a lot, right? Machines should be doing that for us. And then the augmentation of expertise, right? The tasks that we do that are super hard, where we really want to actually use all the data and everything that we can around the world. The team of researchers that I run, I think we focus on two things. About half of them focus on what I call invisible AI, right? It's the things that the better you do, the better you solve the problem, it just sort of disappears, right? It's what reconnects your cell phone when it drops. It's what optimizes traffic in a network. It's what really makes the things work that we do today, because these systems are getting highly, highly complicated, and how we orchestrate them becomes a critical aspect. But then the next piece of that, right, and we talk about 5G networks and we talk about the sort of communications trends that are happening, is the applications that are going to run on top of that network. And I think those are as exciting, because the productivity increases we come from optimizing industry, optimizing enterprise, utilizing intelligence to solve scarcity across all industries that utilize the network for the communication, for the computation, is really the exciting piece. And the last thing, and I'll say just in one point, when I talk about AI to people who maybe get a little scared about it, is I liken where we are with the internet right now to black and white TV, right? Right now we're dealing with the black and white internet. And we all, well, some of us, are old enough to know that transition from black and white to color TV. We thought black and white was great. When we saw color, we thought, wow, how could we have dealt with the black and white television? Well, we're all using the black and white internet right now. 10 years, and it might just be 10 years, we're going to have the color internet, really, which is the thing that enables all these applications to come together. And that's the exciting piece for me and the folks that I manage that actually try to understand how this world is going to evolve.
Yeah, definitely an exciting portent of the future.
Yeah.
Michael.
Yeah, so I lead Consumer Technology's policy work on artificial intelligence, and Consumer Technology Association, $351 billion trade association, or representing $351 billion industry. Sorry, we're not quite that valuable. Our industry is. And supporting millions and millions of jobs in the US, we are focused on making sure there's a policy environment that makes sure that AI can improve people's lives, right? And the important thing is to look at how AI is being used. If you were to approach it as a monolith, we're going to have an AI policy, it simply doesn't work. You talk about AI's applications in healthcare, analyzing sensitive patient data, making life or death decisions, or aiding in those decisions at least. They are different implications than when AI is helping a farmer precision apply pesticides, precision apply fertilizers to make sure that he's optimizing his crop yields. We need to make sure to view these policies in their unique verticals and have a discussion about how does AI affect serious issues around jobs, around data security, around bias in each of these areas, and what's the appropriate approach to make sure that the technologies can thrive, improve lives, but that we also address some of these serious issues that AI does raise. And on the other panel, we heard about being realistic about those concerns. What we find in the policy space often is that concerns around AI are often framed by severe hypotheticals. They're framed by a science fiction type reality. I don't want to discourage people from reading science fiction, right? It can be a useful tool for envisioning hypothetical futures. But when we're talking about policy, I think we need to have very real discussions about how AI is being used today. And as has been mentioned, that is analyzing large amounts of data very efficiently, or in other cases, I recently read, as I'm sure many of you did, the McKinsey study on AI for good applications. And one thing that came out of there was good enough, right? You have a disaster situation where you need to quickly survey with drones, analyze images from the ground, and determine whether or not a road is passable. A human could go do that. You could go out and survey it perfectly fine. You can't do it efficiently. And an AI system might not be able to do it as well as a person, but in that kind of split-second environment, It's better to get it pretty good across the board. That's why we need to make sure to have policy that's flexible, that's adaptive, and that is unique to the different applications of AI. And that's what we're working on with the federal agencies and with Capitol Hill right now.
Well, thanks for that. Turning to our next panelist, this agency is a very strong believer in the power that lies at the intersection of technology and healthcare. And Sue, you've been a leader on those issues. We'd be interested to hear your perspective as well.
Great. Thank you so much, Chairman Pai and Eric, for inviting me to be on this panel. So I work in this really fascinating field of precision medicine. And when people say, what are the types of data that you all work on in your artificial intelligence, machine learning data and methodologies, I always try to draw this analogy for people. So if those of you who remember the CD-ROMs, my son doesn't know what that is, but the 1.6 millimeter round things where we would actually store data. If you actually stack up the amount of data we collect for precision medicine, which is the genotype, phenotype information, so all the genes that we measure, genes and proteins that we measure in humans and participants and patients, and connecting them to data from electronic medical records and other data from participants through mobile technology, through sensors and others. If you put that data on these CD-ROMs and you stack them, you can go from Earth to the moon and a quarter of a way back. So that's the kind of data we're actually dealing with, right? So every time you're trying to design a novel clinical trial or ask the question, are immunotherapies going to benefit this patient with brain tumor? There's all kinds of other useful information, not just from this patient, but from other patients that we have previously collected, from electronic medical records, from literature that we can apply to this problem. So those are the kinds of interesting challenges we work on at Georgetown. So let me just bring you into my world and expose you to some key projects that we're working on. So the first one I wanted to talk about was virtual tumor boards, right? So 14.5 million patients live with cancer today in the United States. And when they go to one of these tertiary care cancer facilities like ours, so Georgetown Lombardi Cancer Center takes care of many patients with advanced metastatic cancer. So when they walk in the door, not all of them get boarded, as we call them, right? So there are these tumor boards where pathologists and radiologists and oncologists get together and discuss these complicated cases. So especially when you're generating precision medicine type data, not one person is an expert on that particular gene pathway, so you need to get the groups together. And that's where telehealth and mHealth technologies really enable these tumor boards. Not everybody gets boarded, right? So because these are busy clinicians, they get together at 7 a.m. in the morning, and they can only review maybe once a month. They can review 3 or 4 cases, right? So how could we, using AI and machine learning technologies, really enable these tumor board discussions where we could bring together data from radiologists and pathologists and electronic medical records and genome testing to really augment treatment planning for these patients? And I think there were sort of these tongue-in-the-cheek comments about radiologists losing their jobs, and I kid about this. I don't think it's the doctors that are going to lose their jobs. It's actually the doctors who don't adopt AI that are going to lose their jobs, right? So that's really true. It's the human in the loop, which I think is what we all need to think about. I think the AI and the technology will continue to evolve, but how do you effectively incorporate the human in the loop? And it's very critical in the medical field because these are experts and there's a lot of clinical knowledge that need to sort of work together with AI to make this happen. So I'll give you one concrete example. So I was in one of those 7 a.m. tumor board meetings recently, and we were looking at a breast cancer patient's image. It was a radiological image, and there was one lesion that the AI had detected, right? So this was just machine to machine. The PACS system had communicated to the AI, and they had detected this lesion and said, oh, it's a small enough size lesion. It's less than so many millimeters, so we're just going to do a hormonal therapy for this patient. And thank goodness we were discussing that in the tumor board discussion. When the radiologists and the oncologists saw that, they immediately saw the satellite lesions for this image, which the machine had not detected. And they said, we absolutely need to add a chemotherapy to this hormonal treatment that the machine had planned for this patient. So I think that's where, so to make the point that humans and machines need to work together, and how could we, as agencies who are thinking about sort of regulating the technology, not just to, we want the innovation to move forward, but at the same time, how do we effectively engage experts along with technology to make these things happen? So Eric mentioned the MOOC so one of the things we think about, and we're a higher ed organization, how do we train the next generation of data scientists in this field? And it's not trivial. We don't have Dr. Raos everywhere at every university to, train our students. So it's very important to think about what are the right educational programs, what are micro-certifications, so people might come from different fields, might take a micro-certification set of courses to really become experts in this field. I mean, that is really the challenge right now. It's a bottleneck, not having enough people who understand the methodologies and the data. So we're actually launching this master's program. Just putting a quick plug here for master's program in health informatics and data science. Would love to engage experts here within that program. It's not passive entertainment anymore. All of these courses are going to have workshops, hands-on. You work with real data from electronic medical records and train the next gen to really make a huge impact with AI. And the third and the last example, really keeping me up at night these days, is thinking about mental health issues. So we work on this problem called IPV. How many of you know what IPV is in mental health? Have you read about it? It's intimate partner violence. Right? So it's 35% of women in the world are affected by this problem. 35%. So that's a pretty large number. And many of them actually don't know that they're actually experiencing this. And this is a perfect application of digital technologies and AI, right? So if I joke that there are more cell phones than toilets in the country that I hail from. I come from India. And really, there are more cell phones than toilets, right? And so imagine the amount of information you could collect, just voice recordings of people who are actually talking into the phone to stratify patients who are experiencing IPV, right? So if there was a good control group and a case group where we could analyze the audio files, so we're actually doing this at Georgetown with a deep collaboration with our Department of Psychiatry, where we have these audio recordings of women who experienced IPV sexual abuse in their lives, and comparing that to how somebody else who is not experiencing IPV would talk about how they enjoyed Thanksgiving holiday, for example. I mean, even simple descriptions like that could be extremely illuminating in stratifying risk and who needs intervention, who doesn't need intervention in terms of mental health. So that's, just to kind of give you an exposure of the types of projects that we're working on, and none of this could happen without mHealth and telehealth. So we're in the right place talking about health.
A terrific perspective. And just so you know, I'm pleased to make the administrative announcement. I have asked our staff to look at cloning Raos. So we'll see. We can replicate his voice now using some of those algorithms. And the work is underway. So stay tuned. Last but certainly not least, we want to turn to Yongbin for your perspective and what Qualcomm and you are doing to explore the application of AI to communications.
Thanks, Chairman, for inviting us to this discussion. And it was very fun sitting there, the presentation by Professor Rao, all the good stuff, until I heard the comment that the AI is going to replace all the engineering work. And that's when my heart just sank to the floor, because I'm trained as engineers. Anyhow, so, like Eric was saying, Qualcomm is a technology company working on wireless, what we're doing with AI. So there's a couple of aspects about AI relevant to Qualcomm. We just at the beginning of 5G, the first release of 5G just got published in the past couple of years, a couple of months, and we're gonna start to see some commercial rollout of 5G service next year. So one of the things about 5G is we're gonna see much faster link. The service will be more versatile, and we're gonna use higher frequency band, and also that means we're going to have a lot of small cells and so on. So the consequence of that is the network just become much larger than we anticipated. So with such huge amount of cell sites and devices, we actually have the accessibility of a lot of data. And how do you deal with all this kind of data? That's where AI comes in. So as engineer, there was a lot of discussion about how AI is going to interact with humans psychologically, all this and that. But from the engineer perspective, we treat AI or machine learning just as a tool. And for engineers, we like new tools. As long as the new tools does the job for us, we're good. So definitely, the machine learning AI will play a factor in terms of how do we improve the the performance efficiency of 5G network as the system get rolled out. The other thing, relevant, AI relevant to Qualcomm is the mobile platform. Now probably more than like 8 billion of mobile devices there is the biggest platform and has a huge amount of computation power built in. So if you open your smartphones, you have all the GPUs, DSPs, CPUs, all the sensors, and so on. So with all this data comes in, what are you going to do with it? Today, all the intelligence are largely stay in the cloud. So if you do your Alexa, your Google inquiries, all go to cloud. So with the vast amount of device and the computation power at device, we actually envision where certain part of the intelligence will stay on the edge, which is wireless edge, where you can do certain things. And we actually have a demo over there that if you are interested, we can take show you to that. So using AI as a tool to improve the network, optimization and efficiency, how to use spectrum more efficiently, and how to use the gigantic platform of mobile smartphones and tablets to push some intelligence to the edge. This is what we're focusing on.
Great, that's an excellent perspective. And I think Chris offered a very useful analogy for framing our discussion. I mean, obviously you're talking about different areas, but as you put it, we're dealing with the black and white internet we have, and in the future, we're going to see one in color. I'd be curious to explore, from your view at least, what that color future looks like, whether it is spectrum management or healthcare or video. And if we might go in the reverse order, what is the future, say, 5 to 10 years from now? And if I might ask a second question, is there anything the government can or should be doing to help encourage that future, to nurture those consumer and competitive benefits that your various initiatives are trying to secure? Yongbin?
Yes, one of the things that Qualcomm have been working actively is how to use the unlicensed or shared spectrum more efficiently. In the past couple of years, we have been working actively to, traditionally you think about unlicensed spectrum, mostly is Wi-Fi and so on. But in the past couple of years, we have been actively working to bring cellular technology into the unlicensed band, and also how to in the shared band, so that the customers and service provider get more options. So as we kind of dealing with more complicated coexistence issues and so on, one thing we're struggling is how do we learn each other of different technologies and systems so that we can coexist better, and also how to use the spectrum more efficiently. And so that's where we're actively working on using AI and machine learning as part of that. Now, there's this open question of regulation versus how industry can work together, solve issues. I think there's a open question there. We should have more dialogue on that.
I think we talked about standards and data sharing in the previous panel discussion, and I think that's clearly an area in a sort of a pre-competitive realm where the government plays a major role in enabling innovation, right? So for example, I think the biggest challenge in implementing precision medicine, we actually wrote a review article about this, in the U.S. healthcare system is really lack of standards, because we have every company that's generating a precision medicine profile on a patient has their own data model and have their own standards, and ultimately we do need to combine and compare and contrast those data sets when you're designing a clinical trial. Somebody might come from Georgetown, somebody might come from Arizona, somebody might come from a community clinic, right? So I think thinking about what are some common data models that present this data in a computable form for clinical decision making, I think is very important for us to really take AI to the next level. So you asked what the color television looks like in precision medicine. I mean, I don't think we're going to get away from having diverse set of testing and data generating operations. But I think what we want to make sure is that when those different systems generate these precision medicine data, that they're able to talk to one another. There are APIs and data standards that allow them to communicate with each other, and also that same data gets communicated into electronic medical records so that the physicians at the point of care can actually utilize that information, right? So that would be sort of on my wish list for how the future looks like is there is seamless interoperability between data sets so that they are most effectively used in clinical care.
So right now, a lot of the exciting things happening in artificial intelligence are tests, small pilot projects, or very leading edge companies putting something out to market. We'll see that become much more ubiquitous, right? Whether it's in cybersecurity, whether it's in healthcare, whether it's in agriculture, AI is not accessible across the board at this point. It's not being used across the board at this point in most cases. I think as mundane as it sounds, we'll start seeing some of these exciting tests that we get sometimes a little bit too ambitious about right now, about saying this is the AI future today. It actually will be the future once these tests come to fruition, once these beta projects come to fruition, and you start seeing AI applying benefits to people more across the board in these industries. Now, what'll be fun is that color television in 5 years, imagine what'll be on the test phase, right? What's going to be tried out in 5 years when we're more ubiquitously using these things that are brand new technologies today? What can government do to help facilitate this? I talked a little bit about pursuing AI specifically in different verticals and applying regulation to those areas. Another thing that I'm excited about, and Congressman Will Hurd and Congresswoman Robin Kelly have been pushing this on Capitol Hill with their series of hearings, is the government owns an enormous amount of data, right? The government can not only be a encourager and facilitator of AI, it can be actively part of bringing AI benefits to people by using that data internally for its own benefits and opening that data when appropriate for other benefits that are pursued by researchers, that are pursued by companies, that can then be applied more broadly. So that would be the specific and more near-term thing that the government could do. Long-term, we are going to have to address some of these issues around bias, around data security, and around jobs that I brought up. And that needs to be collaborative between industry and government, and it needs to be prudent. We can't just ignore these problems and pretend that they don't exist. They are real. There will be job market changes due to artificial intelligence and automation technologies. It's a matter of industry being proactive about that and communicating clearly the problems that they are able to solve and where it may be more appropriate for government to step in with their resources and expertise and scale to help make sure that people are trained, for example, for the jobs of the future.
Great. Chris?
Okay, thank you. I think that if we look at the network now, it's very much a consumptive model, right? People consume data. I think where we're going to start seeing the colors start to come in is a more interactive model. And that means that human communication is going to include not just verbal. It's going to start having all the other pieces, emotional communication, all the other things that we can now use AI systems to try to learn and actually process and send. Human cognition, right? The ability to augment us, right? It's a shame that if people were going to sit down and think about a new problem right now, the tool they would use is paper and pencil, right? So mobile cave painting is the best that we've got to assist our thinking, right? Augmented intelligence, where we're going to be able to make ourselves smarter by interacting with each other, by interacting with the data of the world, is going to dramatically change the way we do things. From an industrial side, right, the amount of productivity that we can actually start to encourage, the growth in productivity from automating all aspects of how we move things around, logistically, right resource, right time, right place. The amount of data that we can actually gather from around the world and actually operationalize, to go from big data, which relevance is not really there, to small data, right? The key data that allows us to answer a question or make a decision is really what is going to be facilitated by AI in the future. And the key to all these things, if we bring it back, because Nokia is a vendor that sells 5G and makes that network go forward, the key to this is the complexity of the underlying network is also getting so large that no individual human could actually configure it, could understand it. We need to have AI to actually optimize the resources that we use in order to enable these new kinds of applications. And I think that's where government regulation comes in place, which is we need to actually facilitate the ability for rapid dynamic reconfiguration always matching the supply that we have, right? The transmission over spectrum, the transmission over wireline, optimize that to match the demand of the applications that we have. And we really see that as being a huge potential as these new applications come on board, their ability to impact how the network runs and how the network is used in a very dynamic and a sort of optimized fashion is really where AI allows us to take the things that we could do individually on one problem or one person and take it to scale. So it's about intelligence at scale and the interactivity that I think we're going to be able to see that really sort of excites me about where things are going.
And last one at least, Matt.
Sure. I think that in terms of what's going to happen in the next sort of 5 years, I can see more extremely well-trained models being made public. Professor Rao touched on Google BERT in one of his slides being released recently. So this is Google's. Google has produced a natural language model based on essentially every piece of published text ever published by humans. I mean, this is absolutely incredible, and they've made this free. And there's a Python library, and you can access this. I can see more models like this being released, and more tasks in sort of niches of computer science, such as natural language processing, essentially being solved. I mean, there's a task, tokenization in natural language processing, which is where you split up a sentence into its kind of composite parts, which is actually a kind of non-trivial problem, especially if you get to things like hyphenated words, contractions, and it's just, you don't need anything more than that now. So that's kind of amazing, and I see more companies doing things like that. Secondly, just the kind of ease of use of AI now. Even I'd say 3-4 years ago, things like deep learning, convolutional neural networks were pretty inaccessible unless you were a very good mathematician. And nowadays with libraries such as TensorFlow and PyTorch, I really see this being extremely straightforward for a more kind of standard software developer to implement things. There are another library, there's one called Spacey, which is sort of, there was one called NLTK for natural language processing before. Now it's called Spacey. It's the documentation is fantastic. It's all there. I'd say as a junior Python developer, you can implement very advanced natural language processing with it. So that's in the next 5 years. I just see it getting even easier and even better models being made public. But a little bit further in the future, I think there are two things I'd like to touch on. Learning on smaller data sets is something that we really need to do. I believe it was it David who made the point about his daughter learning what a cat was based on 2 examples. So right now our approach is more data means trumps better algorithms, and that works for now. You know, Google has the entire corpus of human knowledge, but you know, what if we just have 2 examples? So for example, last week I was building a spam detector at work. This is fine for Google if they're doing email spam. They're very good at this. You know, you typically nowadays don't get in your inbox someone trying to sell you fake watches or things like that. That's just right in the spam box. But a very specific application like Frame.io, where we might have very few examples of a spammer, how are we going to stop that? Or what if somebody new comes along that we've never even thought of? It really requires somebody to manually tag these, and you know that can't last at scale when people can keep on thinking of more and more innovative ways to get past these filters. How can we beat this sort of cat and mouse game there? Yeah.
Great. Now, one of the things that was mentioned earlier and has been mentioned since repeatedly is 5G. And the FCC is focused like a laser on maintaining U.S. leadership in 5G. It's a national priority, so we're pushing a lot of spectrum out there, trying to get the infrastructure in place. And I'd be curious to get the perspective from any of the panelists who are interested in sharing on how AI could affect 5G, what synergies could be involved, and how could 5G networks themselves be optimized through the use of AI, machine learning, and other advanced technologies. And whoever would like to take a bite, Young Bin.
Yeah, I can give some thoughts about that. we're actually very glad to say the FCC has been, keep releasing more and more spectrum to the industry. So for low, middle, or higher band, those are all very much needed for 5G deployment. Just think about all the amount of the base station device out there. It's going to be much, much larger scale in the coming years compared to what we have today. I think that's where you have basically you think about the 5G, there are two aspects of it. One is the operational aspect of the 5G network. So that's where, how do you manage your, traffic routing or your mobility of devices, and how do you to make sure there's no coverage loss or all those kind of things. Now, with the new channel 5G, which is, the network is going to be more virtualized. What do we call virtualized? Basically, a lot of the processing that are distributed today, more likely is going to be pulled into your computer room. And because of the centralization of all the processing, now you do have access to a huge amount of data. Then the question is, how do you use those data efficiently? I think Ms. Wright was talking about the network complexity, exactly the situation we're facing. That's where AI will come in. I think that AI will play a major factor in the coming years on 5G deployment. The other thing is aspect about 5G is because of much wider bandwidth, much higher throughput, and the number of devices will be a lot. So the amount of data that will be collected or present in those devices is also a huge amount. Then the question is, how do we use those devices in the most efficient way so we can extract more value to the customer and also improve the user experience of those things, the customers. And that's where the machine learning can also be a factor.
I think you pointed out something that's important, that 5G will be aided by AI, right? The network management aspects of this, but it's a symbiotic relationship, right? 5G will facilitate an enormous new amount of connected devices. Artificial intelligence-based connected devices, right? So as 5G develops, artificial intelligence can develop, and it can continue helping advance the development of 5G. So I think they very much go hand in hand, and they're two overarching features that we expect to see at this year's CES, both artificial intelligence and 5G crossing across all of our major verticals that we're touching.
Yeah, so I'd like to touch on this because it's a topic we talk about a lot. 5G makes an enormous number of promises, right? It has the potential to revolutionize industries because we have tightly controlled latency, tightly controlled bandwidth. We have the ability to have virtualized network slices that are actually enabling very specific applications that we couldn't have done with the networks before. But that comes at a cost in the sense that these networks then become very, very complex, right? And the ability to actually cost effectively run a network requires that you've actually automated the network, right? If you don't have automation, there's no way this complex system is ever going to work. And more than just the cost, the reliability is also requires that you have a network that's self-healing, that actually looks at itself and is constantly looking for failures, constantly adjusting systems, constantly changing the traffic, and using all the data that's being collected by the network in order to actually optimize how the network actually runs, right? And it comes back to, again, this idea of scarcity, right? If you have billions of devices trying to share the amount of spectrum that we have, right, which is a fixed resource, we don't have the ability to get more spectrum, we need to be actually utilizing that spectrum in the best way possible at any given point in time and any given point in space. And the only way to do that at scale, at the speeds that we need in order to enable these applications, is to have AI systems that actually run and enable us to optimize the network. And I think to your point, that same intelligence that we've been using to optimize the flow in the network, right, and we've been doing this for years, and this is just an extension, really can now be faced upwards towards the applications and allow us to optimize, all aspects of how we sort of digitize our physical world and optimize those physical resources in the same way that we've been optimizing our digital resources. And that's the sort of huge benefit that's going to come from the building of these 5G networks. We can utilize it to increase productivity across the economy and across the industry.
And that reminds me, one of the other questions I have is, what is the most difficult thing about getting an AI or machine learning-based system to work from a technical perspective or policy perspective? Are there any barriers that we should be thinking about that stand in the way of that kind of exciting future you've been talking about, Matt?
Yeah, I'd say 80% of my time is spent preparing the data set just for the machine learning and data science afterwards. The final 20% is the fun bit where you can look at your results and you can pontificate about them, or I think this is causing this and stuff like that, and tweak it. But just getting your feature selections, this is deciding what in your data set you can use. So for example, I use spam detection, or if we're trying to surface the best sales leads, what kind of people's titles should we look at if we're trying to find a good sales lead? It's a director or a producer, Frame.io. What kind of activity can we look at? Some initial activity when somebody signs on, when they're just kind of scoping out our app to maybe, this could be someone very high ranked to their company, and maybe we can identify that kind of behavior. And choosing these features takes a huge amount of time, and you have to get it. There's a lot of kind of manual oversight there, and as well in terms of difficulty, just having enough data, which is why I touched on before, being able to learn on smaller data sets.
Yeah, I completely agree with what Matt's saying. We call it data janitorial services,
yes.
Right? So we're actually, I think we're going to have position descriptions that say data janitor. I mean, we in fact, when we recruit people, now we're, talking about how quickly can they pre-process the data. I think the downstream, the fun part, everybody can do and they're trained to do, but how quickly can you do the pre-processing is, I think, a major challenge. And AI can help with that, right? So I think the more we train our systems to process the same kinds of processing, although it's a little tricky with healthcare data because there's a lot of missing data, and training on small data sets, I think was mentioned earlier. I hate it when statisticians say we don't have enough data to build this model, because you're never going to have enough data, right? And so how do we work with these smaller data sets? And even if you have all this data you put on the CD-ROM, you can go to the moon and come back. When you start subsetting that information to a particular type of cancer, to a particular type of gene mutation, you end up having a very small bin with very small numbers. So I think learning how to model with small data, I think, is very critical. And I think another challenge I'll mention is usability, I think, which was also mentioned earlier. So we did this really interesting study. It's an eye tracking study, right? So companies like Amazon do this all the time. Where do I put the ad so that you'll go click on it on the website? So we used the same eye tracking technology to study how clinicians look at the molecular diagnostic reports, right? So when a test report comes back to the physician, it's a 60-page document. And when we did the heat map, it was fascinating from the eye tracking study that they actually look at a very small component of that entire report for their treatment planning. And it's actually that one table or one or two pieces of information from that 60-page. So I think, how do we make the output from AI really usable at point of care? I think for healthcare is going to be, I think it's still a very big challenge. And how do we train the non-technical people to consume this data? So speaking of sort of training next gen, so we had this massive open online course called Demystifying Biomedical Big Data, and this was primarily targeted to people who are afraid of the terminal. They don't want to write a single line of code, but they want to consume and use this information. We had 6,000 people register in 2 sessions in the last year from around the world. So I think, how do we make sort of the output of this not available just to the geeks who are in the room, but to the people who are actually going to be using it?
Yeah, there's one more thing. I would completely concur that the data preparation, collection, that's a huge amount of work, we're facing every day. The other thing, challenge we're thinking about is the power consumption of machine learning. Nowadays, there's a huge amount of power being, utilized for machine learning. I guess the famous example would be the Bitcoin mining consume a huge amount of electricity. So the question is, as we have more and more AI processing with all the training and so on, how do we improve or reduce the power consumption as part of the AI initiative? That's where some of the low power computation of AI, at least from Qualcomm's perspective, is important. And that's what we are actually pushing from our products and so on.
Do you have a sense, any of you, since you brought it up, do you have a sense of where the state of research is with respect to power consumption at that level? Are we making breakthroughs? Are we still in the initial stages?
Again, this is probably going to be a shameless advertisement for Qualcomm. So one of the thing about the smartphone is a very low power consumption in terms of if you normalize by the amount of computation. And we have been putting all the neural processing in our products, and those are basically can handled by the battery on your smartphones, can consume only a power of a couple of watts. Obviously, this is not training. This is mostly for inference, and that's what we're contributing as Qualcomm. And we have been in multiple generations of our neural processing unit in our products, and also other companies in the industry, the leading ones, also have a corresponding neural processing unit in their products that come along with low power consumption for AI.
Another challenge that we face is not necessarily a technical one. Our companies, frankly, complain about an access to talent, right? We don't have enough people to execute these exciting innovations, right? There may be exciting possibilities to apply AI in any given field, and the cost and difficulty of acquiring someone with the technical expertise is frankly not possible for a lot of people. And that touches on a lot of specific policies that the government can make an impact on. Immigration certainly is one of them, right? We have people that come here to study at our world-class universities, and if we had an avenue to take many of those individuals who study highly technical fields, employ them at US companies, that's a strategic advantage for us. Certainly there's other education reforms that would help make sure that people who go to study, beginning in elementary and middle schools and high schools in America, also are getting on a path to learn some of these technical skills. But it's one very simple way and not necessarily technical way that the government can aid in making sure that we maintain a leadership role in this space.
Yeah.
Can I add two points?
Sure.
One off of this and back to the liberal arts education. One of the things.
All right, keep out. Yes.
No. But this is actually critical. So I have folks on my team who are mathematicians who build interfaces that mathematicians like, and that's how you get Excel, right? You get that kind of view. But the only way this works, the only way we're going to use AI to augment people's intelligence and we're going to interact with is if we build interfaces that are natural and humans actually feel. It's not something that's I'm not using a tool, it's a natural part of the way I interact with the world. So that sort of design, understanding, sociology, psychology, understanding how we think and how we use things is going to be critically important. And I agree, we have a deficit of both technically skilled and people skilled in that art that we really need as a country to sort of build this up. And then to sort of go back a little bit on the power consumption, the danger I always see in AI is, do you trust it? Right? So Jan LeCun, who many of you probably know, has an interesting slide where he shows a very high-end car, like a Lamborghini, in Highway 1 in California, and it goes around a turn and it flies off and goes into the water. And he says, great, all we need is 50,000 more cars and we'll be able to make it around that turn. Right? And that's the danger of data, and that's the danger of some of these models where you might not have the constraints built in and you might not know the failure modes. Right? So we spend a lot of effort trying to understand the models themselves, right? The fundamental basis of what we're trying to do with an AI system. So there needs to be lots of technical expertise and understanding of the systems. And there needs to be an evolution, because I'm going to disagree a little bit with the data piece. So data is always, you're never going to have enough data. It's always going to be there. So what we need is AI systems that learn with limited data, not in the same model of sort of convolutional neural networks or deep learning, but any kind of system that actually provides some level of learning, some parameterization based upon the data. So it's the merger of scientific models, algorithms that we've been doing for forever, with learned models that allow us to sort of contextualize something on top of a physical understanding that's going to be critical. So there's scientific advances that are needed, I think, in order to make this broadly acceptable as well.
And if I could key off that for a second in terms of broad acceptability, and I'd be curious to get the perspective from Matt and Suba, but any of you who might also have something to share, how substantial is that cultural gap? If you're talking to people in the visual arts, if you're talking to medical professionals who heretofore have not had to grapple with these types of AI and machine learning technologies, how is that a big barrier, or is it something that we think organically will happen on its own?
I don't know if it'll happen organically, but I think the resources are there if you would like to dedicate a month or two to learn these things. There are organizations. I'm part of something called Data Carpentry, and there's something called Software Carpentry as well, which it's totally pro bono, visit universities, research departments with a huge amount of data who don't know how to crunch it immediately and would like to learn some sort of basic data science. The resources are definitely there, but it would have to become some sort of part of a high school curriculum in order to make it really ubiquitous. I see a lot of efforts towards teaching high school children how to code, things like that. I haven't seen a huge amount that's come out of that. I mean, there is a steady flow of software engineers coming out of universities, but it's definitely not enough to meet demand. So I totally agree with everyone else on this panel that it's very hard to hire people with the right kind of expertise. I'd also just like to touch on the mention of power consumption. I think the average software engineer is not really concerned enough with the kind of power consumption and that goes on when we deploy these SaaS software to scale. So that's software as a service, this cloud software. The entire startup economy is running essentially on AWS, that's Amazon's web service, and also Microsoft Azure and Google Cloud. And you can write all this code and you can put it on a server and you sort of set it and forget it. It's scaled to 500,000 people, great. And there's sort of a disconnect there. Not because people aren't concerned, I think it's not something that's talked about very much. I have heard that there are a few efforts, like Facebook has an enormous data center on the side of a mountain where they use cool mountain air to cool down the servers. But that's a very special case, and I think there should be a lot more concern there.
I mean, in terms of culture, let's face it, clinicians are extremely overburdened, and they don't have those 2 months to sit down and learn a new software program. And I think really the burden is on us who are developing these new technologies to not throw it over the wall to the clinicians, but actually work with them and understand their challenges and present information in such a way that it's not just a mathematical interface, but it's actually something that clinicians can consume. We did a large study with the Pancreatic Cancer Advocacy Network Group, which is the largest pancreatic cancer advocacy organization in the country, for 2,000 patients with pancreatic cancer around the United States, and they were all treated by different clinicians across the nation. And this virtual tumor board supported the analysis of integrating the clinical data and the molecular data. And the amount of time that went from, so each individual case, when they didn't have the AI platform, took them almost a day or two to analyze once all the information was integrated, to almost less than 20 minutes once the information was integrated. So I think it's important to make the case as to why and how it can help them do their jobs better. I think it's important for data scientists to be able to tell those stories from data so that you could get the buy-in from the end users. So definitely there is pushback, definitely there's lack of enough teaching and learning tools for end users, but unless we do that, the wider adoption will not be there.
Right. So believe it or not, we have actually hit on the noon hour. But before we close, I did want to turn the floor over to each of you for any closing remarks you might care to make, or if there's some aspect of the problem that you haven't had a chance to discuss thus far. Maybe Yongbin, if you could start us off.
Sure. Probably, let me repeat what I said early on. Basically, we see this new emerging things, two big things. One's 5G, the other one's AI. And from our perspective, actually, there's a lot of concern about, AI is going to replace humans, all this and that. But, from our perspective, the combination of these two new things is going to be have a huge potential to change people's life in the coming years. We are actually very optimistic about, the combination of these two.
So it's never about the technology, right? It's always about the people. It's about the people who build the technology, who use the technology. So I was part of the Blue Ribbon panel that Vice President Biden had organized when he was in office, and we were talking about what are the best ways to share data to enable innovation using machine learning and artificial intelligence. And two major groups were missing from that meeting, and they were namely electronic medical record vendors, people who actually build the EHRs, and pharma companies, right? And so this is what we told them. We said, if you really want to make progress with this, you need to have the real stakeholders, the big guys in the room, so that we could all. So I think somebody was kidding earlier, the liberal arts education. I think we need that multidisciplinary people who enable that multidisciplinary team communications and that leadership. So let's focus on that. I think we're focusing on engineering and technology development. I think it's very important to focus on the people that can make that technology, put that technology technology to good use in the society.
Michael.
The U.S. has always had a leadership role in the tech age, and it's been based on public sector research and light touch prudent regulation and private sector innovation, right? They all go together, and they have maintained a wonderful position for our country. As policymakers are thinking about AI, how do we make new policies around AI, it's important to think about that context and what has worked in the past and make sure that we're approaching it in that same perspective. We're in a similar global race that we've been in other economic times, where you have European nations, Asian nations vying for a leadership role in artificial intelligence that no one can take for granted, right? And so as policymakers, we need to strategically think about how does the U.S. maintain the leadership role in artificial intelligence, not just for the sake of owning it, but because it's beneficial to people. If we are innovating here in the United States, we're creating products, we have control over the ability of how those products get used. And as industry and as government, we can make sure that they're put to use in ways that truly make people's lives better.
Great. Chris?
As a lab leader in Bell Labs, I'm supposed to say technology, technology, technology. But the reality is it's all about the human needs, right? If you're not solving for a fundamental human need, you're developing technology for technology's sake, and that never is a good thing to do. AI is about dealing with scarcity, right? It's about solving problems, and it's really the only way to deal with scarcity at scale, right? So think about the things that you do every day that don't require all of your mental prowess, but that you would love for something to sort of take over that job, right? Driving in traffic, right? Automating the mundane, AI has the potential to do that. And then think about the hard problem that you think, wow, that's impossibly hard for me to solve. Think about AI actually making the complexity of that problem much simpler. So think about AI as being an amplifier that actually makes really, really big problems smaller and really, really complicated problems easier. And if we do that, then there's a lot of things that we can do in society that we couldn't have done before. And I think that's the real potential that we have.
Matt, anything in closing?
Sure. I'd say there's quite a lot of doom and gloom about AI, how it could take over people's jobs, be kind of weaponized and things like that. But I think it's important to remember that AI is still conceptually fairly crude. All we're doing is we're saying, here are a bunch of examples of cats, here are a bunch of examples of dogs. Given this new picture, is it closer to the cat or the dog? That's the fundamental of so many different algorithms. And
it was Ostrich, I think.
Yes, Ostrich. Whereas actually, in our lives, we're already using AI in so many different areas, but sort of in an unexpected area. For example, if you look at your iPhone, when it picks out the faces of your friends, you can categorize your photos very, very quickly. That's hours and hours, if not years and years of research have gone into just that small feature, or your job search, or even like a recipe search or a product recommendation on Amazon. That's all powered by AI. Historical research, for example, is, I think AI is helping the humanities as well. Historical research on things like Google Books, where they've performed OCR on all these historical documents and books. You can search through them as a researcher. It's touched so many people's lives in sort of underappreciated ways. To sort of summarize, I'd say sort of give AI a chance. It's a technology that is actually quite friendly.
I think that's a perfect way to close. Thank you so much, Matt, for framing it as such. And it falls to me to offer a coda to this forum on artificial intelligence and machine learning. And I have to extend my thanks, first and foremost, to all of the panelists on both the first and the second panel, to Rao Kambapati for the keynote, to Dr. Carolyn Nguyen, and to Dr. David Cox of Watson for participating in the first panel, and on this panel as well. Thanks to Matt Rutley, to Chris White, Michael Hayes, Suma Bhavan, and Yongbin Wei for offering your perspectives. I also want to thank some of the folks who helped put this together. Needless to say, this was not me and my mug doing the laboring work on this. First and foremost, Nathan Lemur, policy advisor in my office, did heroic work rounding up some of the best and brightest experts we have in these fields and bringing them together for this conversation. Our chief technology officer, Eric Berger, as well, played an important role. I also want to recognize Joel Thayer of the App Association. I don't know if he's here, but he was very, very helpful to us in giving us suggestions on people who might be interesting to talk to, as well as Charlie Meisch, who was formerly of the FCC and now is on the outside, who was a very useful resource for us, as well as John Howells of CCIA and Austin Carson of NVIDIA for helping make this a success. I also want to recognize that this forum doesn't end with these panels. We'll have about 2 hours of demonstrations that anyone here in the room can take a look at, and we would encourage you to do so. We have a number of different demo participants, Era, Frame.io, IBM, Connectica, Microsoft, NVIDIA, Podometrics, Qualcomm, and Verizon. And so each of the exhibitors, thank you for taking the time to show folks here who are interested a little bit of a glimpse of the future. You know, I find myself in the paradoxical position of having spent a few hours talking to you, all of you, and I feel like we learned a lot, but it also illuminated how much more we have to learn. I think that's a hallmark of a very successful panel. So thank you again for sharing your expertise with us. We look forward to continuing the conversation both in the virtual and real worlds, and thanks to all of you for your attention. We're now adjourned.